let's take it real soon. You know we got what you need, baby, so take it real on.
Award-winning trailblazers. A snapshot of Spain's AM industry. AM for architecture. cutting-edge products on the show floor. These are today's top stories on Formnext News. Live from the Frankfurt Fairgrounds, we bring you the latest updates and essential stories from the world of additive manufacturing. The winners of the Formnext Awards 2024 were announced yesterday in a ceremonial event. In 6 categories, innovative companies and individuals were recognized for their groundbreaking contributions to the 3D printing industry. The awardees are Axolotl Biosciences, Oryx Medicals, Certizit, Siemens 3D Process Research Consortium, Fraunhofer IGCV and University of Stuttgart. BEAM, led by scientists from the Technical University of Darmstadt, connects researchers and users in 3D printing for construction. At Formnext, the network showcased solutions including bio-based materials, large-scale applications, and AI-driven processes. Yesterday's symposium covered the latest developments and challenges in additive manufacturing for construction.
It delivers that the community comes together. We see all the technologies they show, we see them being interested in these technologies, and we also see that it really builds a community.
I'm an architect, computational design specialist, and this is one of the places where you can see the advancements in technology, get an idea of what is really happening.
Well, we are on the verge of cutting-edge technology, and we are really trying to get the newest ideas and to really also communicate with the people that do research. So we are trying to bridge the gap between the research and the industrialization. So here's the best place to get new ideas.
Spain has been announced as the partner country for Formnext 2025. During yesterday's morning talk, representatives from Spanish associations shared insights into the nation's additive manufacturing landscape, which covers the entire value chain. Spain's growing AM community is vibrant and agile, with increasing applications, for example, in medical, healthcare, and machine tool sectors. There are also notable developments in functional footwear, further highlighting Spain's evolving role in the additive manufacturing industry. The PowerShot X is a versatile new automated blasting system from Dimension, offering 3 modes: cleaning, surfacing, or a combined process, adapting to various production needs. According to the company, its easy mode switching and scalability make it ideal for dynamic workflows, while its low investment and reduced operational costs ensure a quick return on investment.
Because right now it's all about cost efficiency, and we created a machine that is more cost efficient. It saves space because we consolidated processes in one machine. So it is just more efficient, more reliable, and brings the quality that Dimension is famous for to everywhere in the world now.
Visitech's MCX4K motion system introduces advanced solutions for industrial-scale 3D printing. It uses true 4K resolution and stacked DLP light engines to enable precise stitching across larger build areas. The system's motion stage technology ensures consistent accuracy and scalability without quality loss and supports applications where precision and efficiency are essential. Today, on the industry stage, the focus is on AI and AM. Join us for insightful talks and discussions on the role of artificial intelligence in additive manufacturing. In August 2025, Formnext Asia Shenzhen will be held at the Shenzhen World Exhibition and Convention Center. The event will showcase the full additive manufacturing process and feature forums and seminars on AM technologies and applications, tailored to regional interests and promoting adoption in China.
I might have picked a slightly unsuitable outfit for a business event like Formnext 2024, but I might just find somewhere where it's exactly right. Follow me. Wow. Hi, I'm Sylv. What's this?
Hey, I'm Cosma. This is a moon rover. Students like me built it to take part at a challenge called NASA Rover Challenge in the US.
I'm impressed. Can I jump in?
Yes,
Take a ride?
Take a seat and let's go.
Wonder how fast this goes. I'm a bit scared.
We'll be surprised.
Hold on tight. Ah! Cosma, does it have a horn?
Of course.
This is fun. It's great. Woo! Do you need a license to drive it?
No, on the streets you don't need any license, but you should be sure that you are able to drive this vehicle.
Yes, well, it's pretty hard. You know, it's good leg work.
How was it?
It was a hell of a ride. That's great, thanks. Oh, wow, thank you so much. That was fun.
I'm happy you liked it.
Loved it, great. Are any of these parts 3D printed?
We now mainly use it for prototyping, but let's see what the future brings.
Let's see what the future brings. Who knows? In the future there might be entire carts printed in 3D, except for the wheels, of course. Artists that specialize in 3D. Yes, it's possible here at Suto's booth. Let's have a look.
We are artists that are using 3D as a tool since a few years, and we love it. We fell in love and we deep dived into it.
I wonder how they choose their motors when designing for the 3D printer.
Since we are artists, we always create concepts for series, and in combination with the 3D printing, it's always for us important that we have like a message that we transport through the art.
I wonder if there are any restrictions in terms of shape and size for 3D printing in art. Or maybe it's only in my brain.
No, not really, and we always try to get a little further there. So we have our own print workshop with SLA printers, FDM printers. We have upcycled filament makers and shredders, so we can create our own filament. And we also do cooperations with other concerns here from the fair, for example, Builder Extreme or Photocentric, where we create big showpieces and make cooperations and cross-communication projects.
I wonder if 3D printing is the way to enlightenment.
Good morning, ladies and gentlemen, here on day 4 of the Formnext 2024, here at the industry stage with a fantastic program to come. It's incredible, it's already the last day of Formnext. Time quickly flies by and we experienced, heard and seen so much. But if you thought we might ease up the last day, I must disappoint you, because even on our last day we have a fantastic program to come. It's all about artificial intelligence, and secondly, we kick off the day with a super important topic in our industry. We're going to talk about the AM Navigator. In order to do so, I have some very important persons here in my panel, so let me introduce them. To my left, Dr. Carsten Häuser. Carsten, good to have you here. You are Vice President for Additive Manufacturing at Siemens Digital Industries, correct?
Good morning, yes.
Good morning,
Thank
Carsten,
you.
good to have you. Felix Ewald, CEO and co-founder of Dimension. Felix, good to have you.
Good to be here, thank you.
Then we have new in the round of AM Navigator, we'll talk about this later, Andreas Langfeld, who's President EMEA and APAC at Stratasys. Andreas, good to have you here.
Thank you.
Then a person I don't need to introduce, it's Christoph Stücker, who is Vice President Formnext at Messago Messe Frankfurt. Christoph, good to have you.
Hello, good morning.
And of course, my partner in crime, Frank Jablonski. Frank, good to have you.
Sven, a pleasure.
Yeah. So, Carsten, we are going to talk about AMI Navigator. So my first question would be, it was introduced exactly 1 year ago here at Formnext 2023. How has it been so far? What are the results after 1 year?
Yeah, actually, we started with the idea 1.5 years ago, then had first companies by November last year to introduce it. You would normally say it was a minimal viable model at this time.
Yeah.
So the idea, we tested the idea, we had the first concept for the model itself. But then during the year, we continuously worked on that. A new topic is that we expanded our tech companies joining us with Stratasys. The second one is we worked on the model itself. So in the meantime, we have more than 150 descriptions how to successfully industrialize additive, part of a 10-chapter kind of manual for the AMI Navigator. We work with user. We've had user conferences to work on, learn from the producer, the designer. One example we have here as well, and we started to have what we call transformational insights. So if you go from one step to the other, what would be a best recipe, practice to do so? So we started to collect this. Now it's much more mature. We all signed a contract, and now we are ready to scale and increase this AMI Navigator further.
Very good. So increasing expansion. Frank, I think we have a short clip that we might introduce here. We had a very interesting interview, but please let us know what it's about. And
yeah, on Wednesday we had Peter Curtis, the CTO, CSO, your boss, I think, from Siemens here on stage. And he said it's still a challenge to provide the orientation in AM. And that was his pointing out the reason why it's so important that he on his level of management is supporting that activity. And yeah, maybe let's have a look what he said.
The key insight in the digitalization space is ecosystems need to be open so that everybody can contribute but also benefit from. Right. It is an offer for the community. The more the merrier. Again, it is really making that precious knowledge available widespread so that we can make everybody, scale up faster, industrialize faster.
So,
Felix, sorry.
Yeah.
Felix, my question to you, he mentioned open ecosystem, the more the better. How do we expand? Because Carsten mentioned it already, you want to expand, you want to get bigger, so how do you expand? What are the criteria to get more, I don't know, do you call them members or inside the AM Navigator?
So, first of all, I think per definition, we tried to create a framework, and a framework is only relevant if many people are using it, if many people are contributing it. So it's clear for us that we are an open framework. And for now, we are 6 members, and we will onboard now more members. There is quite some interest out there, and we will do this now in the next months to just onboard more people directly to the consortium. But the good thing is you don't need directly to be part of the consortium to contribute.
Yeah.
So Carsten mentioned the transformational insights. This is something that also others can contribute even though they are not part of the consortium. So we don't need necessarily everyone to be part of the core group, but we will open it up in a way that many companies can contribute. And on the website that we will launch soon, we will have some tools then also for the users. And hopefully we will be able to create something where a lot of people contribute and use the framework.
I mean, they're the major player participating. Andreas, you just joined. What was the motivation to join, first of all, and what will be your contribution?
So first of all, it's a good idea, and we like good ideas, so we decided to join. And it's addressing a lot of the needs that our industry has right now. One is there needs to be a better collaboration amongst the OEMs that are providing solutions in 3D printing. And that's an important thing, because from a customer perspective, there is no single company that provides everything that I need in order to adapt 3D printing. Yeah. So the collaboration, one important point, and the other one, it's addressing the need of the customer to understand how to adopt. What are my needs? First of all, what is my level of maturity? And collaborating with different players from the industry, you get many different insights. We provide our insights from the perspective of a hardware solution material provider. So we do understand the pain points of the potential users on that end. But then there is other barriers that need to be crossed, like software or design for additive. So I think the contribution of many players are making this very sound and are really bringing values to the people out there who consider using 3D printing.
So it's very good to have you on board. I think you all agree. Fantastic. And thank you so much. Christoph, from a Formnext perspective, I mean, you probably feel like I do. We observe the industry for years now, and you're much closer than I am. So we are seeing more and more industrialization. What do you think as Formnext of AM Navigator, and how does it help? And how do you gonna plan in the future to probably be part of it or to support it?
Well, first of all, our job is to bring the AM community here together in Frankfurt, and we manage to, well, I think we do a good job so far with 4 exhibition halls full of technology technology providers. And then the next job is to bring visitors here, potential clients for you, and potential adopters of AM. And that's a big task. And to do that, we also put on these stage programs to inspire them, to give them an approach to AM. But at the same time, you can never go that deep into the technology to give them a real approach. It's just to inspire them, really. And the next step, the next logical step, is to give them maybe that framework to create shortlists, to be educated when you come here. You have a shortlist of potential technologies that you should look at and maybe find your way through Formnext more easily in the future. And that's why it's very interesting for us to hopefully and potentially include it in some way in Formnext to make the navigation of Formnext easier.
Yeah, it is. Carsten, I mean, not everybody knows exactly what AM Navigator is. I mean, we all knew it because we introduced it and we talked about the cooperation before. So, I mean, this is a chance as well to inspire new users. So how is it working? Can you give us a brief overview?
I don't know if you have kids. Just assume you come home and your son, your daughter, you give them 1,000 Lego bricks and say, let's build a car, and you build a starship and you say, good luck. Yeah. This is sometimes how customers feel getting a machine, a post-processing, a software piece, but they want to build a rocket engine, they want to build a piece for an electronic part, or they want to build spare part on demands. So it's probably a good choice that you come and say, I have a manual, and you can look through the manual, okay, let's build the starship, and somebody tells you in the manual how to build it. And that's a nice comparison we made for the Navigator. I give you 2 examples how it works. We worked with 1:1 prototype in Dornbirn. So we came together for half a day. The CEO, the engineering head, the quality head, the manufacturing head, and the whole team worked on a lot of posters on these level descriptions. In the first part, we worked, where do you stand in terms of design capabilities, production quality, management, sustainability, in all the different angles. This was already an interesting debate because they didn't have the same opinion where they stand.
Eye-opening for sure, yeah.
And then the second was, where do you want to go in 3 and 5 years? They want to develop from prototype to serial production. This will require changes, adaptations, and transformations from the shop floor, IT, connectivity, management systems. And at the end, they told, in terms of what is the first priority, and gave us homework as tech provider, what we should do to support this transformation. So after half of the day, they still use this as their roadmap in the next weeks, and we know much better how to support as a tech company. Partly as well, we have homework now to do, interfaces, IT, OT integration between machines to make the life easier, more productive and efficient for such a user. And that's how it works in really getting traction under that. And as you mentioned, there will be recipes, examples, we call it transformational insights, and everyone from Formnext, from the industry, can hand in this kind of transformational insights, how to make it happen and how to give examples, what you have done successfully.
Yeah. Felix, I would be interested in, we were talking about Formnext is reflecting the whole process chain, and with your Lego example, I think it's clear that you need the whole process chain. How does AM Navigator reflect the whole process chain? First question. And second question, wouldn't be the red thread through all what we said, the digital twin? That's a question for you, I think. But let's first answer the first question.
Yeah. So we all know in the end it's about the end-to-end solution for the customers. And we just talked about when we go to customers, for them it's not just about one part of the technology. They have clear plans where they want to be. And especially for us, as dimension, we are also using the AM Navigator to show our roadmap to the customers, how we support their needs. And the customers expect from us, the technology providers, that we come up with joint roadmaps. Because, as I said, for them it's not about just scaling one technology. They need to scale the whole factory, and that's why customers are expecting us to work together and come up with joint roadmaps that exactly support their needs.
But do you already have, for each step of the process chain, an equal as a person you can talk to from reflecting, you know, the past processing? You're responsible maybe for the first steps, how to get to a CAD print, but past processing is very various about looking at the different methods. So you need a lot of companies reflecting all the different process chain steps.
I can give you an example. Siemens Mobility is one of the biggest suppliers for the German railway, Deutsche Bahn. They do spare parts on demand on high level already, using a lot of machines from Andy, from Stratasys. Now, coming from the strategy that you need spare parts on demand, it's a good idea to have very small cells, highly flexible, probably not automated, standing in every depot in every world, because it all matters on time between the demand and the delivery. It's not so much probably on the actual cost of the spare part, because if a train stands 1 hour later in a depot, you should better have the part. But then there are other companies here showing producing 4 million metal parts in 4 months. It's probably a good idea to have a highly efficient plant, one facility with a really integrated, we call it digital thread, from the digital twins as well the real machines, and you should better have everything under control, how you have a closed loop of material, how the machines are unpacked, how the transfer of each step is, how you trace your processes. Solutions are totally different depending on the application. Both have a different business model. For the 4 million parts, it's all about cost per part and quality per part, because otherwise you don't make any profit. And then it's the digital twins, but as well the real world, because at the end parts are produced on the real shop floor in machines, and these machines need to nicely work together. But depending on the strategy, solution, recipes, manuals would be slightly different to be successful to earn money with that.
And you can provide that orientation with just 6 companies reflecting the whole different processes you just pointed out.
The 6 companies started this journey.
Exactly.
And in this regard, yes, we probably will have many more as well joining the consortium. We have a long list of companies we are already starting to talk to as well. We always try to complement us in the value chain, material, machine, software, automation, and then on the other side we have the user using this kind of tool, so we will learn as well from them. I had companies like Siemens Energy, they told me at Formnext, hey, if I would have had this 6 years ago, I might have been much faster, or companies like Lego being the leader in really industrial production. So we need their help, their requirements, and then we talk to Formnext, because we have here how many Lego pieces as booths.
So you
how
can
to make manuals as well out of the Lego pieces at Formnext. If someone comes here, has a spare part on demand business case, he probably find a navigation based on this model, where to go
so
and what kind of
you
solutions.
can point out the technology, you must not necessarily point out the company providing the right technology. Did I get it?
Yes.
Yes.
Absolutely.
But I would add to that it's not so much about the detailed content. We don't need to have it figured out 100%. It's more about standardizing also the language that we use in the industry. It's about limiting confusion or avoiding confusion. When you visit Formnext and you see all of those companies, some call it use case, others call it application. And the language that we're using is not standardized. And that leads to potentially a lack of trust into additive manufacturing. And what we need to accomplish is to make people trust that it's a robust manufacturing method that you can use today and not in 10 years. So I think the collaboration, the open and transparent dialogue, also admitting what does not work, is super important for the industry.
And what I see, what you mentioned, Carsten, it's speeding up the process in an incredible way. Because I remember in the past, you might think about what kind of machine do I buy. So then you buy the machine, you start printing parts, and you see, oh, I need to do something with the parts because I can't use them right away. So you probably tackle Felix and say, Felix, what can we do about post-processing? And then you come up to quality control. And then you build it up step by step, and it's time-consuming. It's often very frustrating. And I can assume that if you go into the AM Navigator, it's no longer that you are, I mean, you get a hint where to start probably, but also where it could end. It must not be the whole way, but this is how I understand it. Is that correct?
Yeah, that's correct. And at the end, don't assume that we have all solutions. We have a structured approach you can use as an approach to find a solution. We have these kind of 10 chapters, which are dimensions to look into. But at the end, every company needs to look based on their strategy, their business. Is it automotive, aerospace, railway, different kind of probably standardization required, qualification required. At the end, every company can use the framework, but you need to find your way. It's like in a car. We don't say where to go, but we help you to find the best way to that. But you need to find and you need to decide for you as a company where you want to go. Therefore, the solution still depends on the user, how they use it and use it as a structured approach. And as well as an industry coming up with one model instead of 5, 10, 20 models that we probably sometimes confused our customers with different kind of structures and models in the past.
Heavily, I guess. Felix.
What I would like to add, what's very important to understand with this industrialization model, we are not telling everyone you need to be at level 5, right? I guess in the past, everyone talked about these fully automated factories, but every application, every use case is different. And we definitely are not telling customers you need to be there. With this application, it's really about giving a framework and discussing with the customer what are the right needs in the different dimensions. But it's not that we tell everyone, hey, now we have this framework. The goal is that everyone is at level 5.
Yeah, that would be my next question. I mean, you still stick to the maturity levels. So how do they help the customer in understanding its level? So the maturity level guides you in a certain direction, what still has to be done. Is that the way it works? Or?
Yeah. Exactly.
Felix, one more question. So what is the exact target group of the AMI Navigator? It's mainly the user, isn't it? So how do you advertise it then? Because I mean, inside the industry, if I would ask any provider, the bigger ones, they would say, yeah, I heard of this initiative. But what about the end users that?
I mean, we implement this in our day-to-day discussions with customers.
Yeah.
And I mean, there is great interest. When you show them the concept of the model, when you show them who is contributing to it, there is great interest, and we use it in our day-to-day discussions with customers and discuss with them their needs, and also where we, as dimension, can contribute in which dimensions. And there are also things like design. Yeah, we are a post-processing company. We are not designing is not our core competence. But if we see there is a big need for the customer, we go then to other partners in the consortium, and we do introductions to make sure that the customer is supported in the way it needs to be.
I would say it's a bidirectional way. So we as well do these workshops with customers. We as well want to be challenged by the producer and designer. If they have requirements for the tech industries, please as well challenge us with topics which could bring it to the next level. We are about to publish as well these kind of transformational insights that everyone probably can learn from the others, that it does not need to take another 6 years to come to a level like a Siemens Energy. So we try to publish to, by that, try to accelerate, get more sharing of recipes, and therefore the industry should help to make this more successful for more companies.
One good way for advertising would be to make a link to the universities teaching product design. Do you have contact there already, or is it not your approach? That would be the very first step to get to the future user.
Yeah, first the company started to really solve real daily issues and challenges if you want to design and produce. We probably would have more academics. We have a long list actually from Formnext as well, Fraunhofer, other institutes that are interested to hook up and to put probably more academic content behind it. Highly welcome. So we invite all these companies to provide. It's a continuous improving model. So it will be not finished probably in 1 year. It will be not finished in 2 years. It should continuously improve with more content, and everyone is invited, as well as you, Felix, already mentioned, to contribute. And there are different ways how you can contribute. One additional topic is that we probably cannot fulfill each and every demand within the next 4 weeks, because this is so awesome in terms of requests. So we will continue to have as well a user group where we continuously have virtual calls, give them updates, engage them, and then learn from each other.
So one step after the other.
Let's put it that way. That was, by the way, Carsten, that was a fantastic closing word. I was thinking about asking another question, but we are running out of time. As you see, super interesting topic. And you know what I like about this topic? Then that I can give a shout out to the viewers and users out there. So thank you to all of you here on stage. It was a very fruitful, interesting discussion. I learned a little bit more. Fantastic. Hopefully do our viewers as well. So dear viewers, that was our morning talk with a very specific topic, the AM Navigator. I hope you heard the CTA, the call to action. So go to the guys, get connected, get part of the AMI Navigator. It needs to be growing, because this will empower our industry even more and push the industrialization in our industry. You will enjoy now a little bit of highlights, and after that, we step into the topic of artificial intelligence, and I promise you there will still be humans on stage. See you in a few minutes.
Australia is Formnext's Partner Country 2024, and I'm currently standing in front of Australia's booth, and I'm shortly going to have a chat with Victoria's Commissioner on the topic of AM. How does Australia fit into the AM story?
Well, firstly, it's a pleasure to be here at Formnext. This is the second consecutive year that we're participating, and it's great that Australia is the country partner this year and Victoria is here representing in force. This year we actually have 13 organisations representing Victoria, 3 of them are leading universities. So Victoria has traditionally been the heartland of manufacturing in our country, still accounts for around $33 billion of economic output. And we're starting to see more of a shift into advanced technologies. So it's great to be here. We know that Europe is a leader and Formnext is the world leading show when it comes to additive manufacturing. So it's great to be joining and being part of it.
You just mentioned the universities. Which ones are you talking of?
So we're very fortunate to have 3 of our leading universities from Australia joining us today. So we have RMIT University, Swinburne University, as well as Monash University. The universities play a really important role in driving innovation in this sector and very much working with industry to form new partnerships.
Which sector areas does Victoria have a strength and advantage in?
I would say for us, where we're seeing the most interest and where we have natural strength is in the life sciences and the health sectors. So we have a lot of companies supporting those technologies, but also when it comes to aerospace, transport and defence, Victoria really is a natural leader. So it's great to see that there's those opportunities for us to chase here as well.
Hi Louise, it's nice to be at Formnext again this year. I think in difficult times where the market conditions are difficult, it's very good to have a trade show to meet the visitors and to exchange ideas and trigger the business. Last year we launched some great innovations.
Yeah, we did, and I think in those challenging conditions, productivity is really key for our customers. So last year when we launched the RenAM Ultra series, with Tempus technology, we really launched productivity with no compromise in quality.
We were really successful in various industries. One of it was aerospace, another one energy. I see Mark over there, our business manager from Spain. Hey Mark, we just spoke about our success in aerospace and energy industries. What can you tell us about that?
Exciting times, definitely. We now have machines with 1 laser, 2 lasers and 4 lasers that with technologies such as Tempus and Simlanes are able to give the capacity to our customers to build at a very high productivity that they need with the ideal cost per part.
So it's fair to say we show a very strong evolution based on our innovation which we launched last year.
I have here a good example from Morpheus Designs, that is kind of regulated sectors that they are capable to use the technology in the best possible way.
So what is about our hardware, the new 2 laser machine?
This is a very good example. RenAM 500D, the dual laser is able to give the customers 3 times the throughput of a single laser machine.
That's great stuff. Thank you, Mark. Another big success is the medical industry, where our increased level of productivity helped to make it really in series production.
Yeah, exactly. Chris, can you tell us why medical device customers choose Renishaw?
Sure. Renishaw 500Q Ultra machine users are able to produce high accuracy lattice components which have consistent mechanical properties across the entire bed of the machine. When you combine this technology with Tempus, 4 lasers, a compact machine footprint, and then also competitive pricing, you've got a great offer for the customer.
Thanks, Chris.
Thank you very much. That's great. Wow, it's really great to see how AM makes it in various industries, and I'm really looking forward for the next couple of days here at the show.
Yeah, it really has been a great start to the week.
Hello, ladies and gentlemen, and welcome back here on the industry stage at the Formnext 2024. And we are on day 4 and have fantastic topics in front of us. You know what the problem with AI is? Everybody talks about it. Every one of us is using it already, and most of us are using it the wrong way, because actually we do not understand really of how to truly get most out of AI in a structured and organized manner. Our next speaker is interestingly not very much into additive manufacture, but even more in artificial intelligence, its implementation, and more importantly, the framework you need to have in order to use it properly. He will guide us into the topic, providing us with a better understanding to shape future approaches. Please welcome with me on stage Sebastian Heinz, who is founder and CEO of Stratworks. Sebastian, stage is yours.
Yes, thank you very much for the introduction. My name is Sebastian. I'm the founder of Stratworks and also here from Frankfurt, the founder of the so-called AI Hub Frankfurt, which is a network for companies from the region who are using artificial intelligence and want to accelerate their adoption of the technology. So today we are in this presentation at least not going to talk about additive manufacturing, but we're going to talk about artificial intelligence and more precisely the future of artificial intelligence. So in the next 20 minutes I'm going to give you at least my perspective of how the near future of AI could look like. Unfortunately we do not have really time to look into the far future of AI, which is also a very interesting topic. But the near future, which is, of course, also very interesting. But let's start with a little assessment of the current situation. So I like to start my talks always with a funny meme. And I found this meme on the internet, which in my opinion pretty nicely reflects the current situation when it comes to AI. So there's a massive interest, a massive buzz and hype, obviously, around the technology. So I'm very sure also here, if you wander through the hall of the fair, you see a lot of companies that are using AI, that say they use AI in their products or services. They claim to be AI powered, and so on and so on and so on. However, there is also a little problem with AI at the moment. So in the last 2 years, many companies invested massive amounts of money into the technology. However, there's one big question open, and that question is, when exactly will AI create a substantial amount of value for the organization? And you can see that on the micro level, so at the organizational level, but you can also see it on a macroscopic perspective. So this is what I show you here in this couple of slides that I got from The Economist. And they basically analyzed, okay, do we already see any kinds of indication that AI is creating some kind of substantial value for a company? And the answer in this analysis is no. You cannot see it in the macroeconomic productivity, you cannot see it in the stock prices of the companies who are using it, and you cannot see it in the white-collar employment rates where everybody is talking about the AI is going to take away all of our jobs. So this is not happening at the moment. And this is exactly the big contradiction that most of the companies are facing at the moment. So everyone is investing, but the big value from the technology is still missing. And this is a problem, and this will also be a problem in 2025, where actually many of the experts are saying that the AI bubble is probably going to burst. So let's see if that will happen. But this is not the topic of my presentation today. I want to talk about the far and the near future of AI. So let's talk about the near future. So at the moment, when it comes to the overall AI development, we are still in the very, very early stages of the technology. So what we call artificial narrow intelligence. So narrow intelligence basically means that from the whole spectrum of our human intelligence, AI is capable of doing isolated tasks of intelligence. So for example, computer vision, like seeing or writing or text understanding and stuff like that. So isolated capabilities of human intelligence. But at the moment, we're not really capable to combine all of those isolated capabilities into some kind of general intelligence, right? And this is what everyone is talking about. Artificial general intelligence, kind of next step of the AI evolution, when that actually will happen. So many experts say that that might be in a time range within the next 5 years, that we see much more capable AI models that bring together all of those isolated capabilities and are then able to then even expand on the broader range of tasks. What I want to say with this slide and also with the next slide is that even though we are only at the very, very bottom, at the very, very start and beginning of the AI transformation, we still see amazing things that AI can already do, even though we are that early. And I brought 3 examples that I find very, very interesting and that also have an interesting perspective for the future. The first thing I want to talk about is Agentic AI. So at the moment, for example, if you are using an LLM or a ChatGPT or whatever, we are still in a situation where we as humans, with our human intelligence, need to explicitly tell what the AI should do. For example, I don't know, create a briefing for a project that does this and this and that. Then the AI is basically presenting us some kind of like text or whatever, and then we need to engage in a little ping pong play with the AI until we get the result that we want. Right? So it's still very human intelligence heavy because the AI is still lacking the problem of a general problem solving capability. And this is one of the things that Agentic AI can do. So Agentic AI can also take a more abstract introduction or prompt and then basically breaking it down into the subparts of the problem and then starting to execute. And the big difference between Agentic AI and the LLMs that we see today is that those agents are capable of also using tooling. Right? So they can also interact with third-party systems, they can crawl the web, they can scrape data, they can even build their own API requests to interact with any kind of external system. And this is a big moment for AI because those kinds of technologies are basically enabling to integrate AI far deeper into the value chain that compared to what we are seeing today. And this will probably also be the point where AI will hit a bigger momentum in terms of value creation, because at the moment we are still kind of scratching the surface of value, because like ChatGPT and other LLMs are very difficult to implement far or very deep into the value chain. So this is the first example that we will probably see the big breakthrough next year in 2025. The next thing that in the near future of AI will be a big thing is software engineering. So at the moment, we already are using AI for software engineering. Maybe some of you are also already doing it in a kind of co-pilot setting, like co-creation setting. Like the AI is recommending you chunks of code that you as a developer need to go through, and change some of the parts until it works and integrates nicely into your software. So this is what people are calling software 1.0. Like, from an abstract perspective, you basically, when you're writing a computer program, you're basically only exploring a very, very tiny area of what you could do in terms of software engineering. So if you are a programmer, you know that there are many ways where you that basically enable you to solve a specific problem using coding. But since you only have a very, very limited amount of time, and it takes also a lot of time to type into the computer, you can only explore a very, very tiny fraction of what's actually possible. And this, in my opinion, is the big breakthrough that AI will bring us in software engineering, that by using Agentic AI, by using more advanced coding assistance, by using more autonomous AI programming software, we will be able to explore a much broader range of what's actually possible in software engineering. And I'm not sure if you're aware of that, but everything around us is based on software. Like this monitor is based on software, this camera is based on software, your mobile phones are based on software. So if AI would, for example, only bring like 10 to 20% acceleration of the software engineering process in general, we are living in a completely different universe, right? And this is also one of the tiny things that AI will bring in the near future, that the overall time to software, time to product will be accelerated, which also, of course, leads to a massive acceleration of product development processes all over the world. And I think this is a very, very interesting thing that we can look into the future, into the near future of AI. And the third example that I would like to always stress in my presentations is not only to use AI in business applications. So of course, many, probably all of you are only interested, okay, what can actually AI bring for my company? How can I save money? How can I make more money? How can I be more like timely, and so on and so on. But I think from a, again, broader perspective, probably the biggest impact that AI will have on us as humanity is the acceleration of the scientific process. So does any one of you know what this is? No? This is a nuclear fusion reactor. So this is one of the most promising technologies for the future of humanity in terms of creating electricity. And in that nuclear fusion reactor, you basically have a hot gas that is kind of spinning around in a so-called tokamak. And by spinning that hot gas around a big magnet in the middle, you basically create electricity. The problem with that is that in order to contain the gas into that kind of spinning, you need a very, very complex system of magnets that basically keep the hot gas containment. And this is a very difficult problem in terms of software engineering. And one of the things that, for example, researchers at Google DeepMind are working on, to use AI to basically stabilize that magnetic field around the hot gas in order that it can keep turning and create electricity. And this is just a very, very tiny example of AI and how it's used currently, already today, in the scientific process. Other examples include protein folding, and also, and this is the example that I brought here to maybe also tailor a little bit to the audience, in material sciences, in material discovery. So this is data from a recent study from the MIT, it's just like a couple of weeks old, where the following example happened. Like, one group of researchers was given an AI tool that basically recommends new materials. And the other group is basically doing their research like they've done before. And oh wonder, the group that used AI basically, and you can see it here in the data, created much, much more new materials in the same amount of time, had much more significant patent filings, and also that led to a higher number of product prototypes. So this is what you could expect. There are like hundreds of similar studies out there. The problem with that is that even though like the output by using AI was increased, we were seeing some negative side effects. And the main problem with that was that the group that used AI showed a large decrease in their worker satisfaction. Why is that? And the reason for that is the system basically recommended all of the interesting work to the researcher, and the researcher was basically only there to accept or decline the recommendation. So all of the cognitive work and all of the interesting stuff that researchers are doing was basically carried out by the AI itself. And we are seeing a lot of similar research results indicating that AI, first of all, is basically also capable of doing really creative research work for us. Okay, that's really cool. But on the other side, it has a tremendous impact on the way that we are working. And this is one of the, I think, very, very interesting things that we need to deal in the near future. How is it that we're going to integrate AI into our working processes to leverage the positive effects, but on the other side, integrate it in a way that we as humans actually have a purposeful job? So this is a very controversial topic that where's a lot of discussion at the moment. Another thing that I want to stress is if all of that is true, right? So if all of the big promises of AI become reality, that should lead in the near future into some kind of measurable macroeconomic impact on our productivity. So I showed you here some data from OECD countries over the last 50 years, where you basically see that the per worker productivity is steadily increasing. And this is due to technological advance, right? So 1 hour of work is generating more productivity year after year after year after year. The big question is, what will AI do to this curve? So will it just continue to linearly increase because at the end of the day AI is just another technology, or will it lead to a overproportionate increase of productivity? We don't know yet, but many of the experts are very sure that you actually must expect some kind of stronger proportionate effect over time. And at the same time, as productivity increases, we also see a decrease in the yearly working time of workers on a macroeconomic level. So this is again data from the last decades, and you can see, for example, especially in Germany, the time that people are working on a yearly basis is decreasing. And here again, we must pose the question, what will AI do to that curve? Everyone in Germany is talking about the 4-day week, so maybe AI is an amplifier or acceleration technology for that kind of development. Does it make sense to work less? I don't know, because if you take a look at the data, again, for Germany and also for Europe, all of us should probably work more in order to be competitive. But this is again that kind of contradiction of what we can expect from AI and what we are seeing on the macroeconomical perspective. Again, if all of that productivity increases is true, and if all of that leads to also new business models and new companies that are created around AI here in Germany and in Europe, we must pose the question, what does that mean in terms of dependency? So at the moment, all of the technologies that we are using around AI, 99% of it, is in terms of value creation dependent on the US. And the US does not only provide you the models, they also are in control of the infrastructure and the data to train the models. So all of the relevant layers of value creation are located in the US. And again, if we as Germany and Europe are willing to kind of use AI and to create value for our companies, to build new businesses, to create new value streams and new business models, we always must think that everything that will happen in these areas will be dependent on the US as of today. So the big question for Europe will be, what will be our core contribution to the AI development in the next decade? At the moment, we do not have an answer for that. At the moment, we're just consumers of AI and no producers. And this is a problem. There were some people who tried it. Aleph Alpha was one of them. They basically exited the AI race and started a different business model. So Aleph Alpha is no any longer a competitor on a global scale. There are only maybe 2 companies in Europe that are capable of contributing to the global AI development, and this is Mistral AI from Paris. And at the moment, interesting Black Forest Labs who have some kind of image model. But all of them are already under control of US investors. And this is also a problem here in Germany and Europe. We do not have the investing and venture infrastructure to actually be competitive to for example, the US or Asia. So, Quo Vadis Europe, this is again a look at the data, like the fraction of Europe GDP and market capitalization compared to the rest of the world, and we are on a decline here. Yeah? So we have a big structural problem in terms of innovation. And the next big wave of innovation is AI. So we must ask ourselves the question, what can we do in Germany and in Europe that actually takes that new kind of tool, that new kind of innovative technology, and that we are creating new value out of this technology for our country and basically for Europe, our continent. So, and our chance is probably we will not create any kind of competitor to OpenAI or something like that. This race is over already. But what we can do is we can leverage the technology in our businesses to actually increase the output that we are having to push these curves a little bit up. So this is, in my opinion, the big opportunity that we have at the moment. So in one sentence, AI is on one hand the biggest opportunity in terms of new value creation that we have in Germany and in Europe, but on the other side, probably also the biggest risk because of the dependency to the US and other corporations that are basically building the technology that all of our value creation is based on. So one last slide before my talk is over. So of course, all of that is a kind of speculation into the future. Most of the time, if you take a look in when people are projecting stuff into the future, they are heavily overestimating the short-term effects, but heavily underestimating the long-term effects of a technology. And this is probably also true for AI. At the moment, everyone, including me, is not really capable to say what AI will create in the next 10 or 20 years, right? But I'm very, very sure it will be much, much more profound and much more significant than what we can imagine today. And with those kinds of thoughts, I'm leaving you for the rest of the day. I hope everyone of you took at least one thing from my talk. Thank you very much for your attention.
Awesome. Hey, first of all, it was an awesome presentation.
Thank you.
But it leaves me, and that's the problem, it leaves me kind of scared.
Yes.
And I think this is what most of the time happens. So you're either totally excited or you are probably more on the scared side.
Yes.
I tell you why I'm scared. So what I was not aware of is the, let's say, focused control in the US. That was the first thing, but it's obvious.
Yeah.
If you think about the tools you are heavily using, it's Copilot, it's ChatGPT, and they're all US based basically.
Yeah.
And one thing, as I'm a leadership trainer, what really caught my attention was the thing that people using it are first frustrated in work, and that's the same experience I do, because it has changed my business completely. So what I needed a day or two before, I do it now in, let's say, 30 minutes.
Yep.
But it's not that the same satisfaction, but you saved the time on the one hand, but you couldn't use your creativity, your input, you couldn't build it up. And one single question to sum it all up, will it destroy our creativity?
Yeah, that's a very, very good question. I think in parts it will, and I think in other parts it will actually enhance the creative process. So I think a big moment that we will probably see next year will be conversational AI. So at the moment, probably also for you, you're typing in, your keyboard, and you get something out, and then you type back. So it's actually pretty uninteresting how you interact with the system. But, for example, also with the advanced voice mode of ChatGPT, you can engage in a conversation with the AI and then kind of create new ideas and ping-pong your ideas with it.
I'm using it
exactly.
already. It's
and
awesome.
I think it's awesome. And this is a big amplifier for human creativity. And I think the big lack of creative work as of today when it comes to AI is the problem that we have this kind of communication barrier of the keyboard. But this will go away probably in next year or 2 or 3 years, and then we will be having a conversation with our AI assistants. And this will, I think, lead to an acceleration of our creativity and not to a decrease. So I think that will be my answer to this question.
Sounds good for me, to me. So thank you so much, Sebastian. And the good thing is we will see you in our panel in just a few minutes. So stay tuned because you will get him again and his information in about, let's say half an hour. Sebastian, thank you so much. Big applause for you. So, ladies and gentlemen, you will get a short highlight block, and then afterwards we will meet here again because we have another exciting topic to come. So stay tuned.
Here at EOS, there has been an unveiling ceremony of a new product, and for that reason, we're going to grab us the product manager to talk to him about sustainability.
Sustainability for EOS is a key pillar in our corporate vision, our corporate mission of responsible manufacturing. And sustainability entails a multitude of aspects. It's about zero waste production, and with new materials running on this solution, being able to reuse 80% of the material, you achieve a zero waste production. So when speaking about materials, we continue to serve the existing EOS materials. The world of the nylons, the world of the TPEs, the flame retardant materials, and so on. But we're also introducing 2 materials that are optimized for reuse. And it's not only about the material reuse, it's also about efficiency in your production. Printing faster means more output at the same time, paying into an improved CO2 carbon footprint, and this is what helps you, helps us, helps the industry be more sustainable.
Time's up for traditional industries. Watch out for AM. Welcome to Bosch Advanced Ceramics. Let's be innovative together.
Bosch Advanced Ceramics is a leading contract manufacturer in additive manufacturing of ceramics. Additive manufacturing of ceramics brings new benefits to the customer in terms of design, because previously with conventional technologies, the design was very limited, and now new possibilities open up. I would like to talk about the terminal head, a part that is used in industrial application and that we're already producing in series production, right around 8,000 parts right now. The most important feature are the material properties of that part, because it's used in industrial applications, so the material properties have to be on the same level as the customer is used with conventional manufacturing.
There are many industries who are already leveraging the benefits of advanced ceramics. To name a few, semiconductor, medical are the early adapters for this technology. And the reasons why they are doing it is high requirements on the products. And they are making good use of this technology.
Bosch Advanced Ceramics is having decades of experience in manufacturing of ceramics, and we're leveraging that experience to additive manufacturing of ceramics. And we're already having 10 years of experience working in that field.
It's a very innovative technology because it brings benefits of sustainability with it. This means that the customers, they can reduce their time to market. And also, we are using only as much material what is really needed. And having long-term experience in additive manufacturing for almost a decade, we are the right partners when it comes to the series production.
We accompany our customers along the whole process chain, from material selection to the final ceramic part. Visit us at boschadvancedceramics.com.
Hello, ladies and gentlemen, and welcome back on day 4 here at the industry stage on Formnext 2024. Today it's all about artificial intelligence, and you see, it's all real. I'm still here. We had already a fantastic presentation, and there's another one to come. So, additive manufacturing, and specifically laser powder bed fusion, has revolutionized how we think about producing complex components. That was the thing that catched me the most. However, the path to perfection in this technology is still paved with challenges, especially when it comes to balancing quality, efficiency, and costs. Today, we will hear about how artificial intelligence is playing a transformative role in tackling these challenges and pushing the boundaries of what's possible with laser power bed fusion. And I'm super happy to announce the speaker for the following speech. It's Andreas Börn. He is head of the Swiss Advanced Manufacturing Center, and he will bring us closer to the topic. Andreas, stage is yours. Enjoy.
Thank you for the introduction. I'm very glad that you still stick around and come to this short presentation on the last day of Formnext. My topic is about a digital companion that helps us understand challenges in changing from process development to complex parts. And as my previous speaker, or the previous speaker mentioned, in the meme, I try not to take an even bigger brass instrument and blow some AI stuff at you. I try to explain first the problem that we afterwards solve. So please excuse if there are maybe more tables and numbers than usual, but I try to walk you through. Yeah, let's start. The challenge is, if you want to print a complex part and you start, as also I do, and many of us do, for process development, you start with cubes and test specimens, and you try to transfer this process to a complex part, then often you wonder why it's not working. And many things you can see, others are a bit hidden deep in the data. So we take care about this today. And often, if you are not very sure, you try to increase safety margin, and you end up with a process that is not as productive as it could be. And so what goes wrong? I mean, there are many factors that can play in the difference between a test coupon and the real part. You see some are like kind of random or recurring, that are linked to how you maintain the machine, how you organize your processes. There is human error, the gas flow, everything. It's something you can understand and correct if you track your experiments, your process development. There are spatters, there is a bit of randomness. You can reduce the amount of spatters that you create by optimizing the recipe. You cannot influence where they exactly deposit if it's in a critical part. So there's some randomness that is maybe out of control. But today, we speak about the design-dependent parameters. So it's residual stress, local thermal effects, laser toolpath, and design. So, you know, if you change the design, the laser toolpath also changes. And these effects that are related to the laser toolpath, we try to analyze a little bit more in detail now. So, where do the laser toolpaths come from? Like the laser toolpath is the instructions how the laser scans our layers. There's many influence factors, like the input parameter or the input format, the 3D model, many settings and proprietary filtering and optimization algorithms that are part of the black box of the slicer. You have thousands of layers and you have millions of vectors. If you want to analyze, then you have currently no means than just like scrolling through your files and identify manually some possible problems. So Today we will see how we can do this maybe a bit better. First, I have to include some information about another factor that brings another layer of complexity to our process. It's the response of the optomechanical system of a scanner, because there is a response to what we order from the scanner. Maybe you heard about the polygon delays. So that's the amount of time before a turn the laser starts or the scanner starts to slow down in order to keep the geometry. If there is a small offset in these settings, you can end up with overheating at the end of a vector. You can have an overshoot, and this also adds problems to your part that you are maybe not aware of, because it's the response of the scanner that is responsible for this. Why these delays are important, you see here. That's just an impeller, and you see the contour run. These small blue triangles mark the start and end of a vector. You see it's not a continuous contour. It's assembled from several vector sections. Okay, and if you add delays at the start and end, you may already see that there might be a problem. For turning, so that's now we are at the tip of the blade, and see the contour run. And yeah, I don't explain everything, but you see there are some runs that are taking a short curve. That is if the dynamics of the scanner is not sufficient to fully scan to the edge. So you end up with a geometry error. On the other hand, you see these loops. This is a so-called skywriting. That means the laser shoots at full speed and turns quickly and comes back, and the laser is turned on again once it's over the part. There, if you are too late, too early, you have another possibility for errors. That's a layer that is in between and even makes it more difficult to interpret our errors. So there is some homework to be done. Homework that either the user or the machine integrator has to take care of, but it has to be done. And once this is done, we can start to talk about the toolpath itself. Okay, here you see you see several situations. Now I'm puzzled because it looks different here than here. So, yeah, on the left-hand column you see a skywriting path. The blue is more or less the target speed that our laser reaches. If you see a red section, there means that the laser speed is below 70% of what you ordered from the scanner. And you know that power stays the same. So you add much more energy per length unit than you should actually do. So you introduce skywriting on the left, works well. On the right, you have polygon delays that many of us use in recipes, knowingly or not. And you see if there is a polygon delay that is different from zero, you see that these sections where the speed is not met get quite long. So this can lead to an overheating and a failure of a part. Okay, now you remember the guy scrolling through the recipe manually? The question, can we do better? And yes, we can. We found a solution that actually transport our knowledge, our decades of experience into an algorithm that does the work for you, and it does it quickly. The software is called PAM. It's distributed and commercialized by Gravity Pull Systems. We have Huba Rompoli here for any questions related to the commercialization, to the product, to the licensing. Here I just want to say a few words about how it's interacting with your printing process. So it's integrating in the workflow, in the digital workflow, between the slicing and the printing. So as an input, you need your 3D file as a reference, as a geometrical reference. You need the sliced build shop file, and you need some basic information about your melt pool that you create with your laser. With these three things, we can work. And I do now some examples with you. Increasing complexity, and you see from when it starts to be really effective. So we start with a cube 10 by 10 by 10 millimeters, printed in 316L using a very well-established, well-known recipe. We have 2 contours, a hatch distance of 70 microns. We have a hatch offset from the contour of 25 micron, and we rotate the hatch by 67 degrees between layers. So we expect no porosity. On the right, you see already a preview of the analyzer that you see in PAM. Okay. For another parameter is the short vectors. Short vectors, during short vectors, the laser might have problems to reach a speed. So you try to filter out those. You detect here vectors that are shorter than 150 microns. And you see already in the cube, between layers, you have this you see in the blue one. As you might expect, there is either 0, 1, or 2. And not surprisingly, they are found in the corners of your cube. So very simple and very understandable. Already here, we see that there is a variation in number of vectors per layer. Also, it's no surprise, but it's notable that already in the cube you have different number of vectors per layer. Now we go one step further, and we place 20 cubes of the same kind on a platform. Different location, different angles, and some are on a higher support, so they shifted and set a little bit. Okay, so you would expect probably the same as me. So there is one table. I don't want to say a lot about it. You have a variation in the number of vectors that are scanned between the geometrically identical cubes of 1,500 vectors difference, 6 centimeters of difference in scanned total length, and surprisingly, one cube has 1 layer less. So the slicer just kind of makes the slicer output just makes the geometry 30 micron shorter, and I don't know about this before. So it's a surprise already with the cube. Now we go to a more complex part. It's a very nice pivot mechanism that is based on flexure elements, interlocked lattice flexures. And here you see a stable frame and these flexure elements that are highly critical for fatigue, for porosities that are included in the blades. Here you want the full performance that you expect. And there it's really critical what you get and that you know what you get. We place 14 of these pivot mechanisms on the platform, and we analyze them. And here we see there is some porosity detected, very low, but already the gut feeling tells me it would be good to see where they are. Are they in the frame or in the blade? In the frame, I don't care, but in the blade, yes. And yeah, here we see that's a 3D view. Yeah, you might guess that this is a cross-section of the blade, and these small red spots are predicted porosities in the blade section. Okay. It's a low, but it might be disturbing. The next geometry that we look at is a simple cube, but just added a notch of 60-degree angle, so we are always in the in-skin parameters, so we don't change to down-skin or up-skin parameters, but we remain in the same recipe. The hatch is now rotated by 90 degrees just to make any porosities more visible. And we vary the hatch offset. What you see here is cross-sections through this notch cube. with different hatch offset, like offset of the hatching from the contour. And you see that in the down-facing part, you never find porosities, but in the up-facing part, yes. And in some, you see it in the vertical as well. PAM now predicts this. You see, there is a graph that shows the total porosity area detected or predicted from the digital file. It's not from the build job, it's predicted from the digital data. You see that this correctly predicted for 25 micron hatch offset. Here we switch to 40 micron hatch offset, and it also predicts some porosity in the vertical. You can also see it in the sketch of the toolpath data. This I will skip. There's an effect that you're maybe not aware of. If you create a hatching, the slicer usually creates a hatch on the platform level. And then you add your part and you kind of cut out from the existing hatch the cross-section of your part. So now, depending on where you place your part, it might include or not one vector more or less. And indeed, the variation of the positioning of the vectors that you can get is up to 70 microns. So that's just by placing the part. So this can explain sometimes why placing a part in a different location of the build platform can lead to a different, or like that it can fail in another place if you add more of the same, exactly the same component. Now, there is a way to automatically correct, luckily. So we are not only informed, but we also know we get an assistance in correcting all these predicted porosities. There are several strategies. I don't explain them all, but you can actually, where you detect the porosity, you can add a contour, you can add additional vectors to just fix those pores before they go to the printer. Here we see different build jobs. We compare two of them. So this is still these notch cubes. In the B1, we have the detected porosities, and in B7 there was PAM applying a correction, and we redid the analysis in the same software with the same settings, and it cannot detect any porosity anymore. We can do the test in practice, so there are several correction possibilities. So an added contour, a fraction of a contour, and so on in different orders, several recipes. All were successful except for this, but there was an error that we could track that was coming from outside the algorithm. Yes, so it works. Now we apply this correction algorithm to this pivot mechanism. And you see the difference between the uncorrected and the corrected pivot in the predicted porosity is quite striking. And they carry the scale, it's different. So there might be some peaks left in the upper image or the upper analysis corrected version, but it's much lower than in the one below. You might maybe ask why there is a lot more here and a lot more here. That's just because there is more volume, more part volume. You remember there are these structural rings, and in the middle there are finer structures and basically these flexure elements. Okay, this was successful. If you look at where these corrections were applied, you see that there are quite this red. Well, so these small vectors were added, and those fixed the problem. Now this is only generated data, but you can also actually see it in reality. So you see the top The top two images are the uncorrected build job, and the lower two ones are exactly the same recipe but added correction. And this, I mean, the added build time, sometimes it's a marginal addition, sometimes it's even shorter, but you drastically reduce the amount of scrap that you have out of your process. And this is truly bringing you closer to first time right if you want to go from a cube developed recipe to a complex part. I think the summary we skip, but I would like to recommend if you have any questions or even maybe data with you, take contact with Huba or visit the booth of Gravity Pool in Hall 12, booth 108A, and discuss your problems, your experience. Also challenge Huba with what you might have to say. So thank you very much for your attention and enjoy the rest of the show.
Thank you so much, Andreas, for this wonderful insight. It was highly technical, and I appreciate that, because usually we talk on it more in a general scale. So I'm not an expert, so let me nonetheless ask you one or two questions, if you don't mind. So we have seen at the very end the comparison between corrected pivot and the uncorrected one. So we couldn't see the ratio, but can you give us a figure? So how much is it better after using or integrating AI in the process?
I mean, the scale where one was like 7 times larger scale.
Yeah.
So you can just bring it down to a level that is non-critical. And now that's the beauty of this approach. Depending on how critical your application is, the tolerance for remaining porosities may vary. So you can really plan. But the thing is, it's not. I mean, everybody can live with the risk, but an informed risk management is necessary. So you know how good or how bad it is, and you can set confidence levels for the performance, and this makes it predictable, and it makes you sleep better at night, definitely.
Sleeping better, that would lead me to the customer. Yeah. How do customers perceive it? Is it something you communicate to your customers in order to say we achieved a better quality due to the integration of AI in our assurance?
Yes, I mean, sometimes we have to do some education, and not because people do not care, but this information is hidden in the machine, sometimes in proprietary formats. So you only see what you are allowed to see, and if you don't know for what you have to search, then it's hard to do all this work. So it's a long track of experience that is behind this. So we try to, first we have to explain what can be the source of the problem before we can discuss solution. That makes it hard, and that's also why I try to walk you through some of the thinking that is behind.
Yeah, that's the main topic, I think, how to approach the whole thing. So in terms of duration of the integration, how long did it take you, together with Huba, in order to bring it to a point where you say, now it's usable and feasible and gives us the result we wanted? What was the process behind?
I mean, it's always you have your system that you know it works, and then it's the hard work of making a product out of it is to make it work with any system. That's why we have to approach manufacturers and get access to the format so that we can interact. And this is, we have to explain that this is really an addition that is not adding just another nice tool, but it's actually solving a problem. And people understand, but it's sometimes it's not obvious.
Yeah, Very good. Andreas, thank you so much for this fantastic presentation. I'm looking forward to see Huber in our panel where we talk generally about AI. That was a perfect introduction for the panel, so thank you so much and good luck for the rest of the day and of course for the progress in your initiative. Thank you so much.
Thank you very much for the opportunity, and I would also like to thank my team and everybody contributing to this wonderful, interesting project.
Very good. Thank you so much, Andreas. So, ladies and gentlemen, that was really a deep talk about AI, and I really appreciated that. And please stay tuned. You will enjoy now a few highlights of the Formnext to get even more impressions. And after that, we step into our panel about AI, and I'm pretty sure you will stay tuned. So, see you in a few minutes.
At UPM Additive Solutions, we are a global supply chain provider that focuses on conventional manufacturing, specifically subtractive, to provide tooling and consumables to the additive industry. We use subtractive manufacturing to produce build plates and recoater blades in various alloys, whether to OEM specs or to your unique additive needs. We also offer the full supply chain solution services such as heat treatment all the way through to testing of the part itself and everything in between.
Yeah, what we're most excited about this year is our new product service offerings. Since we started this branch of United Performance Metals, we started with new and refurbished build plates. Since then, we've been able to add powder supply, feedstock supply options, and even post-print processing.
Our customers really benefit from our services because we manage the entire process but the print. This allows them to focus on their value add, and that is designing exceptional parts, printing them, and scaling their production while we do the rest.
Please don't hesitate to reach out. We're excited to collaborate with you and see what solutions we can find to your supply chain problems.
I'm here at the BEAM Symposium and I can't do it too loud, but this is a great place for architects and engineers to get new inspiration on AM.
Summing up the BEAM event up to now, I know it's not over yet, but what's the big news?
The big news? We're really getting to a level that we see these technology in construction. Construction industry is very conservative. Obviously, we don't want that building collapse. So we want the security. And with new technologies, it's always something which takes a decade, 2 decades, 3 decades to get into our construction industry. And we are now at the level that we really see not just the early birds, but more on a common level that these technologies are adapted.
There are so many ideas and so many different levels of ideas, but most of it focuses on the CO2 reduced usage of material in the production as well as in the material itself. So those are the things that I found very exciting.
What you've heard at BEAM so far, is there any technology you can immediately put into a use case when you go home? And if yes, which one would that be?
Yeah, straight away. So we're working on designing 3D printed furniture. One of the problems with 3D printed furniture is that it becomes very heavy very fast because of the techniques within the plastic themselves. And what's really interesting about one of the technologies that we've seen is that they're basically inflating a 3D printed line as it goes around, making it very light. and so it feels like your lawn furniture, right, when they're making it, and this is super interesting for us to integrate to our next piece of furniture.
Here we are. Hello, ladies and gentlemen, and welcome back here on the industry stage at Formnext 2024 at our panel regarding AI. So this panel explores the integration of artificial intelligence and the industrial metaverse into additive manufacturing. It delves into how AI-driven design optimization, predictive maintenance, and quality control are enhancing additive manufacturing processes. And additionally, the discussion highlights the role of the industrial metaverse in creating immersive digital twins and virtual environments that enable real-time collaboration and simulation, leading to more agile and responsive manufacturing workflows. And I tell you what, I'm not an expert, and this is why we got some experts here to the stage. Let me introduce them to you. So, to my left, Gustavo Melo. You are well known, Gustavo. Nevertheless, you are group leader for industrial metaverse at the RWTH Aachen. So this is your main topic. We talk about that later. Yeah. Then we have Sebastian Heinz. You know him already from the very inspiring and scaring presentation. Don't get me wrong, Sebastian. So you are founder and CEO of Statworks. So you are a consulting firm specializing on artificial intelligence. Yes. And then new to the stage, Huber, with a most fantastic name, Huber. I hope I pronounce it correctly. Hörampoli. Is that correct?
Well.
That sounds fantastic. So you are CEO of Gravity Pull Systems. We heard a little bit about it in the speech of Andrea, so we step deeper into that topic. And last but not least, I'm glad to have you back on stage,
Thank
Anthony.
you so much.
Anthony Lille, big applause so for him as well. Founder and CEO of Automation Acoustics. So we dig into that topic as well. Thank you so much, and a big applause for the panelists here.
Thank you.
So, I tell you what, I prepared for the topics, and the thing is, you can't be prepared. Yeah, that's impossible in my opinion. So the first thing I want to do is to hear from you, what is your stake into artificial intelligence and what is your kind of definition, because Sebastian delivered some different definitions, or let's say levels already, and I would be interested, where do you see yourself in your work right now from the maturity level in your artificial intelligence work? Gustavo.
So Zen, thanks very much. Thank you very much here for welcoming me here in the panel. Well, in Aachen, we are really mapping now the possibilities of AI along the process chain of additive manufacturing. Yeah? We're having now some studies made in the ACAM, so the Aachen Center for Additive Manufacturing. We covered design part, the process, the quality assurance, then we kind of map it to understand what is the potential there. But we realized that additive manufacturing is a kind of great base, since additive is quite digital. Yeah. So from this additive, let's put like digital perspective of the manufacturing, you can already collect a lot of data, and this data is quite helpful to be used in additive as well in artificial intelligence. So the point for us is mapping right now, and then we understood that we can apply not only for the process chain, but also for the value chain. So now we are now understanding and applying artificial intelligence to map, for example, customer interest, also to mapping the skills that are needed in the market, and then to try to understand where is the direction that we should go for the development. Yeah? Caring for the design, using AI to accelerate the design. Yeah? Going for the process itself, understanding how to apply the data they collect already in situ process monitoring to discover the defect root cause. Yeah? And last but not least, covering the part of qualification and see, for example, using of AI to map and analyze microstructure, for example.
Very good. Yeah. So we skip you, Sebastian, we take you the last, don't get me wrong. Huber, what is your part in AI? I mean, we heard you are kind of have already an offering, so what are you exactly doing?
Yes, Andreas, I think, explained pretty well our AI offering on the metal printing side, but
I think if you talk about the metaverse, I have a better example which probably shows the opportunities and the challenges of AI combined with the metaverse. And this is maybe just indirectly connected to the AM industry, because one of the applications in a medical application where we AM print biosensors for diagnostics, and we are a member of the HEART project, the HEART, so-called HEART, which is representing the digital twin, which is actually a core component from AI metaverse combination. It's representing the heart, not just the model of the heart, but how a heart is working. So the huge advantage and opportunity is that, for instance, if you have like a new procedure to treat diseases, you can simulate the heart disease, and then you can simulate the treatment of the disease, all the diagnostics, and draw conclusions which is working, which is not. But this is the big opportunity, because of course, we don't have, I probably it's not good word, we don't have that much waste, which is, we are talking about a human body. It's not a waste, of course, but you don't have to really touch the heart and do different things in a physical heart, but you really have the digital twin is working exactly the same, hopefully. So the big opportunity is very clear, but what are the big challenges? The challenge is, of course, that this digital twin has to have a very high fidelity, because the high fidelity is actually an assurance that whatever you get out of this model is going to reflect the real world. So if the AI reaction is not so-called correct, that can have a very serious or even fatal consequences. You don't even know, is that the side effect, what has been generated, is the real one or not, or is it working or not working? So this is one component. And the other component is, most of the project is, of course, the AI part, because the model and the working, what you see with your different devices or the PUI, is just actually the tip of the iceberg of the AI data and the AI model. But how do you know that the AI model is correct if the AI model is a black box?
That's right.
So this is going out so-called responsible AI or ethical AI. So what is my way of making sure when I'm treating or diagnosing patients with a heart disease that it is really the right thing? That's what we're doing here.
Oh, let's
keep
that
questions.
point. Yeah,
Okay.
we're coming back to that later, because a lot of friends of mine are doctors, and if I talk to them about anamnese, it's
Perfect.
very interesting how they approach it, and it's pretty similar to AI, I think. So, Anthony, I mean, I remember your speech when you presented your company, and I remember it's very much focusing, I think we called it machine learning and not that much AI. Nowadays, we would call it AI, right?
Yeah, that's correct. And I guess we use the machine learning at a real-time level. It's all the AI is how we actually look for the patterns. So for us, it's a powerful tool to identify and associate errors and defects that occur from the acoustic emissions and how they correlate with process in real time. So the most important for us, it's just a tool. It's a tool for us to look for these patterns that skilled operators can usually hear, but now in an AM space, you're in closed boxes, you've got micro welding occurring, you've got all these other behaviors, but you can't naturally hear. So the AI gives us a depth in our full spectrum to look for these patterns, associate patterns, and then find other things of high value that our customers say, gee, we didn't know that.
Yeah.
So for us, it's a tool. We keep it in a black box. You're absolutely right. At a operator or at a deployment level, it's the machine learning models we use as an output from our AI. So we separate it into a couple of different groups in how we use it and deploy it.
Very good. Sebastian, coming back to your speech, I mean, we were talking about the levels, and it's like the narrow models we are using right now, and still exploring. I mean, starting with you, you're exploring it. Huber mentioned a very important point. You don't know exactly what is inside the AI. That's sometimes threatening me, don't get me wrong. So, I mean, you have to use a certain model, and you need a lot of data, right? I mean, if you want to simulate a heart, or if you want to simulate a print, or even if you want to analyze the acoustics, you need to know what is a good and what is a bad acoustic.
right.
I mean, if you don't know that, the AI wouldn't help you.
Yeah.
So, how do you generate a model that would help the others? What is the process of generating?
Yeah, so I mean the process of building a model is actually pretty straightforward. Actually, for like 90% of all machine learning models, so you need training data, and you need some kind of quantity that you want to predict. So for example, in your case, you have like audio data, and you can associate all of those samples either if it's a defect, yes or no, right? So this is one of the simplest part of machine learning, like discriminative models. So you take data, and the AI/machine learning model is basically classifying them into different groups. So this is one of the most straightforward cases. And actually, this is also the system that ChatGPT is relying on. So if you take that, like ChatGPT is taking patterns of text, and it's actually like predicting the category of word that's coming next, right?
Yeah.
And you really, if you double click on most of the AI models today, you see that this is the systematic that most of those models are working on. And dependent on the task that you want to solve, you have different kinds of data sources, right? You have audio data, ChatGPT uses text data. If I want to predict sales, I have my sales data, and so on and so on.
Yep.
And this is also, I think you mentioned that he's said it in his post. Actually, if you take the word of AI, like 99% within that word is machine learning, right? And we just associate all of the machine learning models now with artificial intelligence. But at the end of the day, it's still machine learning. All of the, or most of the techniques are pretty well known and developed over the last 50 years. But right now, like with the generative models, we've basically established a kind of new class of machine learning model that for us as human beings has the appearance as if there would be some kind of intelligence behind it, right? Yeah. And if you take a closer look and double click on that also, you see that it's actually not very intelligent in the human sense, but it exhibits some kind of properties of human intelligence. And this was also what I was mentioning in my discussion, that the human intelligence is basically a multidimensional concept, and it has, for example, the ability of pattern recognition, right? And many of the machine learning models can take that ability and be superhuman good at it, right? Yeah. And I think this is the interesting part also of the discussion. When it comes to artificial intelligence, I think it teaches us also a lot about the human intelligence. But I'm very, very sure that if you would like also maybe think a little bit into the future, where you have kind of a like general AI or AGI system, it would probably have nothing to do with how a human brain works. And that's okay, because at the end of the day, it's a tool, and we can use it for our purposes. And that kind of intelligent behavior that we are looking for is probably constructed in a completely different way than compared to how our human brains operate. But I also like to bring one example here. So if you want to build a machine that does something similar, like you see it in the nature, for example, you want to build the fastest running robot on the planet, you take a look at, I don't know, cheetah or like a gepard or whatever, and you build it, right? It has 4 legs and it runs really, really fast. But you could also take 4 tires and put on a jet propulsion engine on top of it, and would go with 1,000 miles an hour through the desert. So it does the same thing, but it operates in a completely different way. And I really like that anecdote when you compare it also to intelligence, right? So there's no need that an AI system must work in the same way as our human brains are to be better in what we are calling human intelligence.
Gustavo, Sebastian mentioned data, so you are exploring the industrial metaverse and how to apply artificial intelligence in additive. So where do you get the data from? Because I mean, with Huber is clear, with Anthony is clear, because they have a specific topic they're working on, or let's call it a focus, yeah? So, but you are looking in a broader range, right?
Exactly.
So are you cooperate with companies that delivering data? Because as we just learned, without data, no AI, right?
Yeah, definitely. I mean, what you just mentioned, additive manufacturing is quite rich with data. Yeah? So then you can start from the design itself. Yeah? When you're already designing, we do a lot of simulations. This simulation is already one type of data that we can use to be and use in AI, or use AI in combination with simulation. So the simulation can take a really long time, and then we apply AI to accelerate the simulation results to target that. This is one application that we see in design and in simulation combined. Yeah. When you go for the process itself, there is a lot of data collected already by the machines. Periphery, temperature, environment, even the noise. We always make like an adult. You intervene a robot, like a microphone in additive, this interview has already been made. There's a lot of interview data there, and then it's not being used. And that's the point now, kind of a call for many companies. It's kind of the AI has been used to improve the productivity, because their markets had been already starting getting red, and a lot of competitors, and now is the point of improving performance of machine regarding cost, regarding sustainability, regarding also quality of surface quality. There's one point that is always described as an issue in AM, right? And last but not least, what we call post-processing. AM is not to be alone. AM is a combination with a hybrid, it's a combination of conventional. So then it's kind of work together with institutes as well, companies that have good experience in the conventional manufacturing. There is a lot of information, there's a lot of knowledge that being applied in conventional manufacturing.
Yeah, my question would be, and who are probably your experience, are they willing to give the data? So I mean,
No.
you had a cooperation now, and you know what I mean. So same with me. Don't get me wrong. Let me be the naive guy here on the stage. Yeah? You give data into ChatGPT, for example, and I clicked. Of course, I don't want to be part of the learning process, because I thought if I do that, of course they will get my IP inside a model, even if it's in a model and it's mixed with 1,000 other things, but I give it in, you know? So what was your experience when starting with AI?
So our experience is very mixed, but basically you are absolutely right. Actually, when you're saying, big question, do you get the data from earlier experiences, that would be actually the idea, that you can merge different experiences like a human evolution. One is actually, I don't have to learn again, you know, how do different things which 1,000 years ago people already figured out. So the same thing with AI. But at the moment, I mean, how should I say, the culture of the AI is still what you I'm trying to explain. Much of our successes was very limited to a corporation or like to a larger, how shall I, ecosystem where you have multiple partners. And don't take me wrong, the benefit is still huge of AI, even then. Of course, it would be much, much bigger if you had, like, you know, the buy-in from so-called like non-participants, not direct participants, but someone who already did the same project. So so we have another system, which is another good example. This is an optimizer for optimizing processes based on AI data, and then very complex systems or very complex processes, so to say. So with simulation capabilities where different variations could be really just mind-blowing. It's just no way a human mind can just really see everything immediately. So that's I like to a little bit extend this discussion to the metaverse. So our thinking was how you can really present the different type of options as solutions, because you have the AI as the data, as you just explained, or the different pattern matching and how this works, and with the machine learning. And sometimes the result is overwhelming, not just the data. So how you present this, you know, to the users. And then one way we've been experimenting different things. So one is like creating a 3D view of the process, whatever the process is, whatever the problem is, that you have like a visual input, a visual presentation of the results. But then, and then you have very different technologies to do that. You have the different goggles and these kind of things. But so my personal experience, and many of people I'm talking to, they are still a little bulky and not very convenient. And then you have to have maybe cables. No, this is not like just you are just walking around. You merge the physical world with something else. So we switched to something like a holographic experiments, which is basically you have no device, just different sensors and the combination of different sensors on the surfaces. You try to generate a holographic view of your real physical world and the result of the AI, whatever it is, combined like the effect on the physical world. But the technology, I think, still not quite there. So it is like either you have a very complicated infrastructure in case like the holographic situation, or you have something which is not really convenient, or even you have sometimes the feeling you are not even part of the real world and you're losing, the connection to the real people.
To the real products,
So those are still, I just summarized it, technology is not quite there. But I think this is the most interesting part. One is, because I think the software side, we always figured out something very quickly. The software, or we will figure it out. We have so many different methods and ways, to slice and dice the data and find the correlations, the matching, and so on and so on. But how to make these actually very practicable in the physical world? Like, for instance, my customers. Okay, I have this very, very complex process. What should I do now? Okay. And then you have still zillions of options. And how do you know which one is the best? Because you also have to make the decision as a person, not just saying, I cannot say as a system, this is always the best. I want to give you the option to say, override it, what the system thinks.
I totally agree on the whole data front. I think your word focus gives us, in some ways, a great advantage, because focus allows us to understand the problem of our customer. And when you understand the problem you're trying to solve, then we collect good data, not big data.
Okay.
And it's a bit of an expression we have internally, because if you get lost in big data and it's not relevant to the problem you're trying to solve, you're just wading through things that aren't contributing to the bigger picture. So how we collect data is just as critical as how we process the data. And that ability to get that from our customers is actually part of the relationships. And so I think over the last 7 years, we've been collecting acoustic data. We've been labeling it as we go. I think we've now ended up with the world's largest acoustic labeled data set for AM, I think, and a lot of other subtractive processes as well. But in doing that, we've been able to put that into our models. And so it's a sort of collective knowledge that is coming from various sources that are all kind of adding to a greater outcome in the models we generate. But without doubt, we've got to be very careful that we're not polluting it. And how are we working with it? How are we questioning what we're getting? And many of our tools internally are also qualifying the outputs. So how do we actually validate what we're getting? How do we... Is that a false positive? Is that something? And how do we confirm that against an audience that may not understand? Or they have no other secondary checking qualification process to say, well, we found something, is that true? And they're like, well, we didn't know. And as we learn on the journey, we've discovered tools that we've got to work with so we can engage with our customers, so they can guide us on their knowledge. We always say the most important and most powerful person in a room is the person standing in front of the machine. They're the ones who feel it. They smell the machine. They listen to the machine. They know it. And it's one of the more important things for our team is to actually spend time watching the machine, watching the behaviors, the operators, and then building that bigger picture so that when we label, when we interrogate, when we qualify our models against the actual and the real world, there's substance of relevancy to the problem we're trying to solve.
This is funny that you mentioned that with the focus. So that would be the issue. So you mentioned it a little bit where you say, today we are at the stage, they are the one tool that can process pictures, the one that can process audio. It's not that mixture already in place. That makes it quite difficult if you have different parameters you have to look at. How to combine that? That would be my question. So let's say you want to check acoustics, you want to check the visuals, probably temperature. How do you create such a model?
Exactly. So this is also one of the, let's say, big discoveries. I would not say, but like recent advances that you can actually process different sources of data at the same time in a single model. So that wasn't really possible before, right? So in my early days when I started out, you had like your toolbox of models that could basically only process structured data. There's kind of tabular data like you have it in an Excel sheet or something, right? Then over time, as the progress with neural networks and deep learning, accelerated, then people started to process image data, right? And they found ways of how the models can basically look at different parts of the image and then maybe classify it and blah blah blah. And then over time, time, and right now we're at the point that the models can basically process arbitrary data inputs, be it tabular data, be it image data, audio data, video data, and so on and so on. And there are already, which I find pretty interesting, companies, for example, that try to model smell, right? Because smell is basically just a chemical compound that you can then transport and transform into some kind of data structure, right? And the new generation of like deep learning models offer you the capability to include any kind of data source into a single model and then to predict some kind of behavior. Maybe if the machine smells funny, yeah, that might be indicative for a defect or something like that. And but this is then not what we are seeing with the generative models right now, because the generative models are basically so-called world models. So they try to understand the world as a whole. Let's put it like this, right? And you cannot just throw in the audio data from the machine and ask if it's broken. This is not how the model is constructed and what it's operating for. However, and this is what I mentioned also in my talk, we see that kind of convergence of models where you basically have a single large model that can process arbitrary inputs, and then with a limited amount of labeled data, for example, you can basically refine it and tailor it to your specific use case. And this is probably the next generation of large foundation models that we will see, like so-called multimodal models that can take arbitrary input at the same time, and then with only some kind of labeled training data, you can tailor it and fine-tune it to your specific use case. So this is probably something that we'll be seeing also in the next, I don't know, 3 to 5 years. Yeah.
And then will probably enable us to check the data as well. So, I mean, you, of course, you're an expert in audio, and you can see the graphs, and you know exactly what this should mean if you work together with your client. But then if you go into the, let's say, multiverse, where you bring this all together, you can, if yours labeled, you can recheck it to other labeled audio, for example, and get it into a perspective. That would be the way.
Exactly.
But Gustavo, let's stay a little bit with the checking of the model, because Anthony brought up a very important point in my opinion. So that's what I always think, and that goes along with what you said with the heart. How do I know that the model is representing the heart correctly? Yeah. So if you get all the data, I mean, you cannot be expert in everything, even not at the RWTH. So you get the data. How do you make sure that the models developed are reflecting the reality? This would be my question. Is that something that you deal with, or?
Currently, generated labeled data or testing, generated really with the physics, because many of the data they're collecting and they're looking for is physics-based, right? And then you're really using the physics principles and collecting and label the data afterwards to make this fine and cross-check. One thing that we're looking for the future, since we're also a research institute and saying like in the long term, and there's a lot of discussion now, how could quantum computing help in this into cross-checking, like breaking this black box? It was also something that I would like also to put here in the question, also put in the round, because there are a lot of discussions about how quantum compute could support exactly to understand machine learning, understand deep learning, understand how the data is now be processed inside, to open the black box. That's something that I would like to also
so
put
there are, as to my understanding, there are different ways to, like different methods to test. The problem, at least what we also, tried one of these things, but the problem what I'm seeing is testing the validity of the AI model takes more time and money than create the model itself.
Yes, that's
this is today the problem. And then you're talking quantum computing, that's probably the solution. I don't know.
That was my thought. I mean, if I need to do the testing, then I can skip AI and do it right away with the testing, right, Anthony? I mean, this is probably how you started. I mean, you needed to collect data. So in the beginning, you got the sound and you compared it to the results. And you say, this sound means defect, this sound means okay, basically.
Simple.
Simple as that. So how can we... how can we prove that the model is correct without doing this extensive testing that would make it obsolete?
Yeah, you cannot really do it, and that's exactly that's exactly also one of the interesting concepts around AI. So you mentioned that basically we are using physics and kind of mathematics to describe the world, right? So this is a tool that mankind has developed in order to understand how things are working in the real world, right? Machine learning is also something that can mimic the behavior of the world without explicitly modeling it. So this is a different approach to describing the reality and making predictions about the real world. And the problem is that you cannot really combine the two worlds at this point in time. So for example, I can use also AI to make prediction about the state of quantum systems without ever having attended a single lecture about quantum physics. Right? So you can make predictions about the world, you can make predictions about if a machine is broken or not without the AI knowing nothing about any machine on this world.
Yep.
And this is the big paradigm shift also in AI, for example, also in the sciences, in physics and mathematics, that you have now predictive tools that are so powerful that make better predictions than if you try to model it with the most difficult formula on this planet. And the core idea behind that is that there is some kind of, let's say, underlying pattern behind what we can observe that machine learning models are capable of capturing without modeling it explicitly in a mathematical way. And I think this is a very, very interesting concept to think about because, for example, if you take the Large Hadron Collider in where is it, in Bern or Genf, Bern or Genf, whatever, right? So you cannot arbitrarily scale this project up, right? We are already at this point that any kind of scientific breakthroughs in that area is correlated with a massive investment, like in the billions and trillions of euros. But we're hitting some kind of wall there. We cannot go bigger than it is right now. However, on the other side, we have now new tools and new methods from machine learning and AI that might be able to predict the behavior of certain kinds of, I don't know, particles or whatever, without explicitly modeling it. Just by observing data, collecting the data, and predicting stuff out of it. And I think this is also a pivotal moment in the sciences, that we might be running into a situation where we enter domains that we cannot really model. However, we can predict it using machine learning and AI. At the cost
by looking at previous results?
Yeah, at previous results, but at the cost of not really understanding what's going on. And this is exactly this is exactly what AI and machine learning at this point, and also ChatGPT does. Nobody can really tell you how ChatGPT is working and like the exact mathematical reason why the things are like they are. It's largely unknown. We just see that it works. And I just want to cite one interesting quote of a professor that I've recently watched in his lecture, and he compared the age of AI to the Bronze Age in the Middle Age, because there people discovered metals, right? So they know they have gold, and you have messing, and you have silver and stuff like that. So they have absolutely no idea about the chemical composition of the metals. So just know that it works.
And they look great.
And they look great, and they're helpful for doing stuff. For example, if you have eisen and you make a hammer out of it, you can do stuff with it. It's a tool, and it's helpful for us. And I think at this point we are in a development of AI, we're in the same stage. We know that it's helpful. We can predict machines, we can make predictions about whatever, quantum computing or just the sales of our products, but we do not really understand how it works. But the question will be, will we ever be able to do that, or are we just reaping the benefits out of the technology for our purposes?
Yeah, and now it comes, probably Huber and Anthony. So you know what my problem is, and let me be quite frankly here. So it's a matter of trust, right? I mean, you want, and you're doing it. It's not about wanting.
No, we're doing it.
You're selling it already. So me as a customer, and they are having the same thoughts. And that's a little bit the problem. The customers are not stupid, so they think the same way. How shall I trust the whole thing? Yeah, that would be basically the question, Anthony. How can I give you trust?
It's you're actually I sometimes call it another language. And the language is not the language of AI. It's a language of prediction and confidence. And when you're presenting back information to a customer, you're almost teaching them a new language to understand what we're giving them and how they'll interact with that. And in many ways, it comes back down to what's the action you derive from that bit of information? And who is the person who needs to make that action? So if you're working at the machine level, the operator, what is the information that operator needs to have sufficient confidence to make an informed decision to do something to prevent a critical issue occurring or something going wrong? So you're presenting information in certain ways, and then, so that's a test in many ways. You're actually asking, and we have had to create very unusual ways to build that relationship, to build that confidence that someone says, actually, this is really good. I get it now. I understand what you're giving me and how it helps me. And actually, I want to help you. And so, again, it comes back to the smartest person in the room at the machine level is the person in front of the machine. So that's how we build confidence in what we do, by engaging with them. And we've had to build techniques to do that. It doesn't exist.
Huber, sorry if I interrupt. That's exactly why I asked Andreas, what is the percentage of improvement? You know what I mean? So if I would be the manager, I would ask, I mean, I fully get what Anthony says. So I get the results, and I want to see how much is the improvement, and is it repeatable?
Yes, this is actually our big, how should I say it, selling point. I mean, we had a couple of projects, we had this experience, sorry interrupting you, is that you print at the end. So you have the proof or not the proof. And if it's not working, then we are not customer-supplier relationship anymore. So it's as simple as it is. In our case, it was very easily, because based on the statistics and the proof, we can confidently say we can eliminate 90% of the problems while increasing 40% efficiency. Those are very powerful numbers. In other words, you have 40% less print time, but you eliminate it at the same time 90% porosity. So this is a nice KPI. So we are lucky in that sense. But you are less lucky with a similar problem, what you just described, a little bit similar with our process optimization, as I explained, which is optimizing processes where I have not just one machine I optimize, what Andreas described based on AI models, but multiples in the entire process. Then, you know, it's difficult. It's getting more complex, because it's not just something you print something physical and you see the result and it's okay, you check it or not. But you either save that much money, but what if I had done something else? I could have saved much more money, let's just say. And here you can put in some so-called breaks, or we call it sanity checks. So we didn't pursue the generic procedures of testing an AI system. We put in our so-called sanity checks. For instance, you don't draw something for a resource which is not available at this point in time. You can check that this is at least this minimum. You can assure customer you are not worse off than when you didn't have this system. So that's probably I can offer. And then otherwise, or we can simulate, we tried actually simulate the human thinking. What is possible humanly to calculate if you have these thousands of different options and different combinations of ways to, optimize a process? A human is capable to see this is a very simple decision. If I have these things available, I immediately use it, and I don't wait and then try to combine it with something else, just like as an example. Try to simulate it, and this is our so-called baseline, and then compare it with the real result. So those are a little bit more practical, how shall I say it, ways of doing this.
Kind of combine the traditional with the future, and then trying to bring this.
There was actually, I think a couple of days ago, a big study about the ability of AI to predict human reasoning. Right? Because we always think our human decision process very, very complex and blah, blah, blah. But actually the study showed that it was a large experiment, I think with 1,000 people that were basically given a variety of different decision tasks, right? Like different situation descriptions. How would you decide? Would you do A, B, C, or whatever scenario it was? And the AI was basically to learn over a couple of hundred data points to predict the human decision outcome at a, I don't know, 90 whatever percent accuracy.
That's not surprising for me because I'm doing leadership, and I can tell you there are some leadership principles, and the reason why we have principles is because we can categorize human beings based on their experience and their seen behavior, and there's like the word cliche is like the oldest word for artificial intelligence in a way.
And exactly, that's the point. Like, and if you get an AI system, like with a couple of 100 data points to a very, very high prediction accuracy, that usually means that the underlying structure and pattern of the problem is very simple. And this is also why ChatGPT, for example, needs billions of data points, because the semantic structure of the language and of the different topics is very, very complicated. So on the opposite, that would mean that actually the human decision-making process is very, very simplistic, and that also reflects the situation that you, I think, described, that if you get too many decision variables, you're out. Right? And you as a human, you always try to decomplex the situation.
Right. Exactly.
And this leads to situations where then, again, with machine learning...
Top 5, top 3, and
what are the top 3 problems?
That's
maybe
exactly
it's more complicated than the top 3. It's maybe the top 30, right? But we cannot comprehend and crunch that information in our brains. And this is exactly where AI and machine learning comes into place. For example, in problems like you are working on, where it's not just a two-dimensional problem, it's a 200-dimensional problem, and humans are very, very bad at those kinds of decisions.
It's such a really good point, that top 3 or 4, and it's always where we start, and it's the ones that I can relate to the most.
Yeah.
And then as we introduce the multimodal approach, and because we're trying to get a foot in both camps, we're trying to start at a very basic level to interact, but we're also trying to do these multimodal, very deep things where we bring other sensory components into this. How is that reasoning that we're expecting a person to do at that point in time and at a critical moment? We can actually start to build those logic controls. We can actually guide and inform based on that, and that's where we're sort of having to balance. But it's absolutely a valid point. Start simple, grow from there.
One topic I really would love to tackle, because we are talking a lot about how it's going to work, what are the restrictions, what are the challenges, etc. But let's get an outlook a little bit for the last couple of minutes. So, we've seen 2 of you are using it already in practical things in additive manufacturing. So I was starting with you. What kind of things we can expect to be? It's not the right word to replace humans in that, let's take design. I've seen a lot of startups already using AI in order to design additive manufactured parts or optimize design, etc. Where do you see the most benefit for AM specific in the next couple of years?
I mean, this combination, I don't think that AI will just cover everything in the design, but it's in the combination of what we called here and described before, industrial metaverse, and giving this possibility to cooperate and co-work with the AI. So we have like a design assistance that will be there, even in a co-space, in virtual co-space, that could give the possibility to interact with my client, directly interactions, and supported by AI. So it's a kind of the idea that I see in the future of this co-working, kind of enhanced by AI, but it's still human-centered. Yeah, so this is what the point that I want to emphasize. We're not just killing all the jobs.
No.
We're just using AI to enhance and capable to tackle tasks that are really complicated for us. We're just saying here about complexity. So part of complexity, treating a lot of data, this one areas, layers of combination of variables. This is also because it's exponential. So you just think about linear. No, it's exponential when you start to add data. Right? Data points and parameters. So from my point of view, try to go, and AM should go on this direction of enhancing the capability of humans.
Then we need to integrate AI into the AM Navigator that we heard this morning. I don't know, the initiative of Siemens and Co. and Dimension, where they want to guide users into AM, because this would be the first contact point to collect data. What are their needs, how they interact with AM, etc. A very good proposal. Huber, what do you think? What will be groundbreaking? Before we ask Sebastian whether it's feasible or not.
Groundbreaking. I mean, from my point of view, at least in my day-to-day business, if you can offer like the magic button and the customer, oh, I'm so happy, I saved so much money with this system, and I'm so much more efficient and can make so much more sales. I mean, this is simply my satisfaction. And I mean, technology is really, really important, and I somehow you feel like in heaven or nirvana when you go all these different models and read them, and at the end, you know, the transition in the practical application, I see that one. I mean, things what we talk about, like checking how efficient the system is, how quickly you have the result of AI. So, for instance, in our case, we had to spend lots of time to tune our system so that, you know, you are directly connected to the physical process. You have like an initial result from the AI, but it's probably valid for the next 10 minutes or 15 minutes because something can be very different, goes wrong, so you need the data continuously for the physical world, and then you have to be able to react on it, but you don't have time to wait 3 hours, you know, for all this computation to finish up and make my decision, because now I have to decide what should I do in the next 2 minutes. So I think those are in a practical data applications, that's what I see.
Yeah.
We'd like to see improvement. Yeah.
One point just to add here, optimization of AI. We always oversee one aspect is regarding the energy used in AI. So it's kind of the sustainability aspect of AI.
Yeah.
As a lot of oversee, and then should be also in the point of discussion, yeah?
Right.
Because you have to optimize because of the time, but think about as well what you optimize about the energy that you're investing in putting there. Yeah?
That would be actually an interesting study to see, you know, all the additional energy spent and saved by the way of the results
of life
AI.
cycle
What is your balance?
Comparing the AI.
Yeah, like a life cycle assessment for AI combined processes.
Yes, generally.
Anthony, let me add something to the question.
Go for it.
Because you're using it already. So are you acting as a role model? Don't get me wrong. In terms of, no. In terms of, are sometimes companies approaching you and saying, hey, you're using it already, can you explain how you use it, despite the acoustics? I mean, not specific to your topic, but they say you're using it successfully. How can we do it as well? Is that something that happens?
No, I actually don't get that. You probably notice, even our marketing, we don't use the word AI on any of our marketing. So it's just one of those things. I guess I'm more modest on that front. But I guess from the future I see, it's always going to be the human-machine interface. Yeah. That's where I see the most powerful in this area. And it's for a number of reasons. One is we've got AM as a new technology. It's a new application. It's a new space. Most of the skill sets are trying to adopt from more traditional skill sets, but they're still different. And you've got people who have not coming through a training program so much. They're not spending time as apprentices working on the tools for 5 years to become specialists. They're put in front of a machine and they're kind of needing to push buttons, or they're expected to interrogate. They're expected to come back to that reasoning. And from our experience, we've never had a machine that behaves as intended perfectly 100% of the time. So a lot of the machines behave in quirky ways. You're working with powders, you're working with fluids, you're working with things that have uncontrolled, weird behaviors. And guiding an operator to quickly put rationale around how to quickly define or diagnose a problem, guide them in that direction, and associate, oh, that noise or that issue or that thing, oh, that machine's telling me this could be the problem. I'm coming back to faster, quicker, solving a problem, getting the machine back into productive state, getting the company to make money, and goes back to that time issue. I'm compressing the time, I'm not wasting time. So I'm finding things like training being an incredible, interesting area where people, you don't lead with a pitch, hey, we're going to save your training time. But training has been an amazing benefit of the things we do. Guidance on problem solving in complex spaces.
Yeah, root cause analysis.
Root cause analysis. And that's all what I'd probably call in the instant time domain phase. But then you've got the post-die, all the data you can dive into at a later point to say, hey, we've made these 500 parts. Why were they changing over time? Because we see a comparison and a variation. And you start to dig back and you can look at a slightly bigger models and say, oh, this input changed here, or that operator was different to this operator. we've actually seen those sorts of patterns and behaviors come out. So we can guide the strangest insights from information we'd never thought were relevant at that time of working into the situation. I think that's probably the most exciting thing we do when you say what's in the future, is the discovery of what is possible from the information and insights we gain, which we don't see as significant value, but our customers go, wow, that's something we can use to our advantage. It makes us a better place to work, it makes us more money, it keeps our employees engaged, they learn something. So these are all very nebulous, but they're really critical and really important to the journey ahead. So again, I kind of avoid the word AI, I avoid the tool, I look at the impact, I look at the ways that people can benefit from it.
Very good closing words. Sorry, guys, we are running out of time. Let me express my big thank you to you, because I tell you what, it was totally different to what I expected in a super positive way, because we haven't prepared so much, we haven't been scripted, and it was super interesting. And I tell you what, even not as an expert, I took so much out of it, and I'm pretty sure our viewers do the same. So thank you so much for being our guest here and share your knowledge and opinions with us. Thank you so much, guys. Yeah, ladies and gentlemen, it couldn't be more interesting, but I tell you what, we even go one step further. So after a short break of highlights, we have another fantastic presentation for you regarding the topic of AI, and I think the four of them will challenge the next speaker for sure. So stay tuned, enjoy the highlights, and see you in a few minutes.
AI Build is a software company. It provides a very advanced platform to generate advanced toolpaths for industrial machines. We have parts from our partners that we have done in collaboration. We have live printing with the KUKA cell. We also have our collaboration with the CNC Robotics, Sika Materials and Total Machining Solutions in UK, as well a beautiful tool from Ingersoll, the Kamoji group, as well some beautiful parts from Fronius. At the fair we offer our software AI Build version 3, which is what we have been working for over a year now, that we are releasing today at Formnext. We have a few capabilities that we are releasing, from automation on making molds that we called Mold Designer. So now the user is able to only import their A surface and automatically create ribs and forklift holes for the manufacturing process. The most important feature of AI Build platform is our unique architecture. It's based into visual programming. That means that we can have very flexible control of the engineering workflows. We can have engineering workflows that are very simple to use, but also very advanced for very complex processes and applications. AI Build is a software company, and the benefit for our customers is our team. They will have close communication with our team at all times. They are specialists, and that reflects on our software. Come to our booth. Our team is here to welcome you. Please visit our website ai-build.com.
We're at the booth of Materialize right now, and they and a few other companies have founded an initiative, the so-called Leading Minds Initiative. What exactly they're up to, we're going to find out right now. Follow me for more.
Well, yesterday here we announced a new consortium called Leading Minds. It's a group of 8 leading companies, including Materialize, that have a common mission. It's twofold, really. One is to increase awareness about the capabilities of 3D printing across various industries, from aerospace to medtech, etc. and also lower the barriers to adoption of the technologies. Companies want to work with 3D printing, they know what the benefits are, but when they try to adopt and scale up on an industrial level, they run into all kinds of problems. And so no single company can address those issues. We need to work together and collaborate to reduce the barriers to adoption and scaling. I think there's by and large two drivers to that. I think one is the shift in the industry. For the past few years, we've been pushing technology as individual companies and innovation, and we'll continue to do that. But there's a shift in the industry from specifically pushing technology and innovation to application approach, application specific, coming up with solutions to specific industry problems. That requires a different approach that not one single company can do. At the same time, we have to recognize our industry is facing some dark clouds. It's difficult in our industry, and so if we want to increase adoption, if we want to make a real difference, we need to collaborate. We need to come together as one group of various companies rather than trying to advance the industry on an individual level. So on the awareness level, driving increased awareness in specific industries, we will go out to these industries and talk about, evangelize about the benefits of AM. So, leaving the AM bubble and going to these industries, I think that's task number one. On the lowering of the barriers to adoption, one of the things, a really practical thing we will be working on is a lexicon of standardized words and terms. Right now, across our industry, companies and people are using different terms to describe the same thing, and it's leading to some confusion, right? So one step is to come up with a domain name model where we identify terms for specific elements of processes and what have you, manufacturing processes. Like what is a build, for example, what constitutes a build, right? So that's a practical example of something that we will work on across the industry.
Welcome to Formnext 2024 and welcome to our industry stage. Yeah, we have the Expert Insight final show keynote right now, so the show is coming to an end, but we have the cherry on the cake for you at the last day. Here at Formnext, we saw tons of products and tons of innovations and solutions of additive. And the kind of red thread through most of the highlight topics here, like skills and talents, or merger and acquisition, or the topic of industrialization, was a question about and how will the future markets develop? And I need to know where to invest. I need to know where to find my company. And as the week is now finally coming to an end, we want to have a kind of a wrap-up look and a market outlook. That is why I'm very happy to have a market insider here on stage who can help us understanding the market growth and the potential. So, dear audience, welcome with me, Dr. Wilderich Heising. Dr. Wilderich Heising is partner and associate director of Boston Consulting Group. And Wilderich, I'm so happy that I have you here with me again. Last year we already shared the stage. Before you start in your presentation, you brought with us exactly for this moment as a wrap-up for the whole fair. I just want to know, Boston Consulting Group, you're a worldwide company, you're looking in so many different technologies, in so many different markets. What's the relevance of AM for you, for your company? And maybe you can add if on a strategic point of view, did it develop or did it change the point of view for you?
Well, thank you very much for the question. And actually, it's an excellent question. So, at BCG, we are doing strategy consulting. So we help companies to develop their strategies to survive and to excel in the environment, in the business environment. And BCG was one of the first consultancy companies that realized the transformatory power of additive manufacturing over 1.5 decades ago, basically, when we started to look into that topic in a more granular basis. So I'm an engineer by background. Of course, I'm excited by technology, but we then started to look at it from a business perspective, and over the time built the team, and I have the honor to lead the additive manufacturing unit at BCG. We have conducted over 75 projects in the ecosystem, working for material players, for equipment providers, for service bureaus, and also for the end user of the technology. That helped me to form the perspective on the market. And for BCG, it's part of our larger Industry 4.0 thinking, and as such, additive manufacturing definitely plays a crucial role in the strategies and innovations and technologies of the future.
When you compare it with other mega trends or trends, that's my question. Is it a mega trend or a trend, or within a trend a trend? We just had the topic of AI and metaverse. When you compare it like this, when you discussing your strategy, how important or where's the place of additive manufacturing in these?
So I mean, we have seen a hype cycle in that industry. So a couple of years ago, everyone thought, wow, that's the next super big thing. And we are now realized that it's a part of the puzzle piece in building a proper strategy for the environment. So I think additive manufacturing definitely has a crucial role in the future in the arsenal of manufacturers to make sure that we bring the best products to the customers at the end of the day. And so additive manufacturing is basically on par with other innovations and building together that bright future actually that we're talking about.
Yeah, future is a right buzzword for me. Then let's have a look at the future you brought with you. Your presentation, Quo Vadis AM, Key Trends in Additive Manufacturing, a Formnext recap. The stage is yours, Wilderich.
Thank you very much. So, well, Quo Vadis Additive Manufacturing. Well, we have experienced 4 super intense days, and we could feel the power of innovation in these halls here in hall number 11 and number 12 of this year's Formnext. So, what I want to do today is to bring you into a quick journey into looking in how is the market looking today and what's the outlook for that, but then really recapping what are the key trends that we could observe here at Formnext and what are the things that will make the change in the future for our industry. So my name is Renishaw. I'm a partner and associate director at the Boston Consulting Group. I joined some 18 years ago. I'm fully focused on operations topics, especially manufacturing and supply chain. And as mentioned, I have the honor to lead our additive manufacturing unit at BCG. And as such, have conducted numerous projects that helped me to form a perspective on the market. And with that, let me dive into today's agenda. So first of all, I would like to go into understanding the market environment that we have today, but also the growth prospects that we see. And then I would like to share with you the 4 key trends that I've seen here at this year's Formnext. Looking into the market potential today, well, it's not a surprise and it's not a secret. When we look in basically around us in additive manufacturing, we see that we are undergoing some rapid change at the moment. So the market is facing headwinds. High cost and lower than expected growth cause some of the players to gradually move out of the market. And what we are seeing is that the additive manufacturing industry is now undergoing a phase or a new phase of consolidation centered around a few equipment manufacturers. So last year and this year also, I mean, we've read a lot about Nanodimension's acquisition, but that's just one to name. So there's a lot of action happening, and that's actually not a bad sign. There's always opportunity in these instances, and what we see with that is, and when we compare to other industries, so that is sort of the cycle that as soon as industries mature, we see that consolidation trend going on. And when we think about Formnext like 5 or 6 or 7 years ago, basically year over year over year, the startup scene on Formnext doubled the space almost. And it's not backed by scientific evidence, but my gut feeling tells me the startup scene this year is rather smaller compared to the last years. And I think that is a normal sign of that an industry is getting more mature and more serious. And that's what we're seeing at the moment. And at the same time, the growth that we basically projected also in the last years where we were at the beginning of the hype cycle or at top of the hype cycle was rather high. And what we see now is that we see slower growth, but it's a more sustainable growth, because what we can also see when we walk around the halls is that there's an increased trend towards manufacturing use cases. And additive manufacturing can capitalize on ongoing trends towards mass customization, decentralized production, and coping with rising product complexity. So all in all, we think that results in a slower, but beyond the hype growth over the next decades and actually next 2 decades, which can be still quite interesting. So, however, there are a couple of things that we need to consider when speaking about growth. So we think that the winners of that consolidation race that I mentioned can still play in a highly attractive but niche market. When we look at the market size today, we are speaking about a market size of roughly 19 billion US dollars all in. When we look at the chart here, that is in contrast to the global manufacturing market. So today we are speaking about 0.1% of the global manufacturing market that additive manufacturing is taking up. Over the next decade, we think that will grow to roughly 90 billion, and then eventually we will speak about a take rate of 1 to 1.5% of the overarching total manufacturing market. That brings me back to the entering question. So how does additive manufacturing play in the world of manufacturing? Well, additive manufacturing will not crowd out traditional manufacturing. That's what these numbers also tell us, with 1% or 1.5% of the global manufacturing market. But it will be a key puzzle piece for some applications, and it will be another tool in the arsenal of manufacturers to bring product to the customers. However, in order to believe in the market, the growth that we see here on the slide, there are also a couple of need-to-believes in that we need to consider. So first of all, I think that the market will see further consolidation. But as mentioned, consolidation is also an opportunity. So I think we will see fewer players that stick around, and these fewer players will be able to continue technology advancement and focus on those technology advancements towards manufacturing. So that means more robustness, more automation, lower cost, and zero readiness of manufacturing at the end of the day. Those fewer players will also be able to drive an active development of new markets and new applications that also focus on secondary value drivers, not just cost. And I will come to those secondary value drivers when I speak about the trends that I see here at Formnext. Moreover, I think that we will see a continued rise of the service business with increasing contract manufacturing offerings, and so becoming a more, let's say, standardized technology that's out there. And the caveat with the whole thing and the whole growth story here is that we will not see any new disruptive technology that will actually crowd out additive manufacturing over the next 10 years. But I have not seen that on the horizon yet. So with that intro into the market, let me now dive into the key highlights and into some of the key trends that will shape the future of additive manufacturing that we have seen here at Formnext. And I see basically 4 key trends that I want to mention today. So the first one is manufacturing readiness. So basically driving that transition to manufacturing applications. I mean, we all started with rapid prototyping, but when we look around each other, when we look around us, then we see that manufacturing readiness is really a key theme this year, and it will continue to be a theme in the next years. And then the second key trend that I see is, on the one hand side, technology, but then also digital and AI. And we just had the panel on AI. So it's a crucial aspect of how we can actually evolve additive manufacturing by going the next step, by boosting additive manufacturing with robustness on the one hand side, technological robustness, but also with AI and end-to-end software solutions that integrate everything together. Thirdly, sustainability efforts. So while that topic was a bit more dominant in the last years, I think, it's still a thing that we see around, and it's still a very important thing. And I want to give it another spin today, and not just speaking about sustainability in terms of how much energy do we actually consume, as we had it on the panel now, or what about recyclability and so on. No, I want to look at it from the customer perspective. So how does basically additive manufacturing support the sustainability agenda of the users of the technology? And the fourth element that I would like to dive in is material innovation and what we can see here. So, long story short, let's dive right into manufacturing readiness. So to boost manufacturing, that really requires a shift towards tailored solutions, which can only be achieved by focusing on use cases and taking a use case-centric view. So that means on the hardware side, we need to move away from one solution that fits all to use case specific systems and functionalities. And when we look around, especially at the hardware players, then we see that this has changed significantly. When we were on Formnext like 4 years ago, everyone was showing their machines. That was on the center of the basically of the booth. Today, maybe there's a machine that stands somewhere at the side, but at the center of the booth, we see use cases and specific functionalities geared towards specific industries. And I think that is a trend that will help to unlock manufacturing applications. Because manufacturers, at the end of the day, they're not so much interested in the technology. They want to know how they can get their problem solved, and the problem is basically a use case that's, or the solution to a problem might be the use case that we see on display. On the material side, we are moving from a closed system to an open or semi-open system where we have tailored materials for tailored applications. And when we walk around, we also see a lot of, cross-fertilization, basically, where equipment players showcase those companies and the materials that they use from other companies, basically, on their booth as well. So that system is, that opening up of the material system is, I think, also a crucial step on the material side. And I will come to the material trends also a little bit later. Then on software and digital workflows, we left the times behind us where there was, one software solution for additive manufacturing. We are seeing tailored digital workflows, tailored AI applications, and so on and so forth, and that will be a trend that we'll also see in the future that will boost manufacturing applications. And then also on the customer support services, typically when we start up with things, then a printer breaks down, the technician would come to the printer, but when we are moving into manufacturing use cases, we will actually move also away from these on-premise support more to remote diagnostics and remote predictive preventive maintenance solutions when we are basically maturing the industry here. So in a nutshell, manufacturing requires us to take a use case-centric view, and in order to do that, we need partnerships for tailored solutions. And speaking about partnerships, I witnessed it. Actually, these are two examples from the Formnext fair this year. Two things that really make me feel very positive about the future of additive manufacturing. So for the couple of years, I was preaching that we need to think about partnership solutions when we want to excel and when we want to bring additive manufacturing to the next level. And I'm very happy to see, for example, the AM Navigator, and we see some iconic brands here that joined forces to build that maturity model for industrializing the additive manufacturing industry and addressing strategy, processes, and organizational readiness. To really, the goal here is to provide structural guidance to the businesses and to the potential users of technology to help them navigate the maze of additive manufacturing and to help them optimize their additive manufacturing processes. Another example that I brought is the Leading Minds Consortium that was established basically also. So the Leading Minds Consortium also, we see a lot of very relevant names in the additive manufacturing world here on that slide. They want to tackle the challenges in adopting and scaling 3D printing technologies. And I think that is a very good sign. These partnerships and this collaborative thinking will help us to bring additive manufacturing to the next level. And speaking about value drivers in additive manufacturing, when we think about manufacturing applications, so of course, direct cost comparison between additively produced parts and traditionally produced parts is an important factor. And I will also come to that development of the savings that additive manufacturing can bring. But it's only, one little element for a user of the technology at the end of the day. There are many more value dimensions. And in additive manufacturing, we need to think about the value that additive manufacturing can bring to the end user of the technology. Because the end user is not interested in the technology. That's sadly truth, but they're not interested in the technology. They're interested in getting their pain points solved and their problems on the shop floor solved when we think about manufacturing. So we need to go there where the problem is, and we need to help the users, the potential users of the technology, identify how we can solve their problem. And then the technology, like additive manufacturing, can play a crucial role in solving that problem. So capacity increase, supply chain resilience, inventory reduction, improved lead times, logistics savings, AM-enabled design choices, ESG benefits, those are all things that are on the mind of manufacturers, and we just need to unlock that value for the users at the end of the day. So I was speaking about the direct cost savings, and when we look at where we are today, and when we also basically take into consideration the progress that we have made over the last couple of years and the way that we have come already over the last years, it's fair to say when we projected into the future that additive manufacturing will definitely disrupt the way we produce. Costs will come down, and as the cost comes down, both on basically the material dimension, on the machine dimension, and also on the labor dimension, because we automate things more, we will be able to lower basically the break-even point, or bring the break-even point to higher volumes that will help us to also unlock new applications at scale for additive manufacturing. I mentioned that I think that the direct cost comparison is only one element. I would like to show you a case study example from a project that I've done recently with a North American player that helps the energy utility companies to basically produce their parts. And before I go deeper into the value that capacity increase can bring to a player, let me first explain a little bit what this company is about. So they produce parts for the utility companies. And in North America, you have roughly 1,000 utility companies. Each of these utility companies use specific, very dedicated tools and very dedicated parts that only this company is doing. So our company, or the company that I brought the case study with, is a supplier to these utility companies. So think about those 1,000 companies, all have very individual parts. So the USP of that company that we're looking here is they can create any complexity that you need for the market. So they have a vast portfolio of 400,000 different stock keeping units. And this is massive. And then at the same time, they have several stock outs due to supply chain shortages. They have a backlog of $1.5 billion in terms of value in the delivery, and they are maxed out in their capacity in their factories. So, and for them, it really doesn't matter whether a part is 2 cents more expensive than before. They need to deliver somehow. And so they didn't want to get rid of the complexity because that's their USP. They want to have their complexity, but they want to be able to double down on this complexity benefit that they have and still be able to reduce the backlog and to supply the products. So what we have done is we thought that about leveraging additive manufacturing and then rolling that out to the low volume products. Because if you have a portfolio of 400,000 units, then of course you have some parts which go with batch sizes of 10,000, 20,000 units, and there you have your traditional manufacturing lines that are super efficient and effective in producing those parts. But at the same time, you also have those batch sizes where you have the batch size of 50, a batch size of 100 units maybe, and that really kills your efficiency and the productivity on the traditional manufacturing lines if you need to do the changeover constantly. So what we've done is we've basically built a tool which is called the AMOS tool, the Additive Manufacturing Opportunity Screening Tool, where we basically put in all these different products and the properties of the products. We validated the technical feasibility. Then in the second step, we assessed the economic viability to move a part from a traditional to an additively manufactured part. And then we identified the best and most suitable additive manufacturing technology to actually produce that part. That unlocked basically a cross-profit impact per year of roughly $100 million US. So quite sizable actually for that company. And how we did that is basically we can see by that illustration here. So think about the low volumes or low volume products, batch size of 50, batch size of 100, that are blocking capacity on your traditional manufacturing line, which you want to really fully utilize, where you want to have highly efficient runs and so on and so forth. But with those low volume series, when we look at a given shift, then we see that basically 25% of the shift was actually production time, and 75% was changeover time, because you needed to change over basically every hour after you had that small production run. And by taking these additive manufacturing volumes off that line, we could unlock the potential, and with larger series, we could now have a production run time of 75%. And just 25% of changeover. So we just swapped that around that relationship, and that really helped the company to reduce their backlog, to focus on where they can add, where basically we add value to the customers at the end of the day. And then it really doesn't matter when the part is 2 cents more expensive. Yeah? So long story short, what I want to say with that is we need to really go into the shoes of or put ourselves into the shoes of the manufacturers and understand where is their problem, how can we create value for them, and the second question then is how can additive manufacturing make a difference here. So my key takeaway for the manufacturing side is basically to unlock growth really requires to rethink how we offer additive manufacturing and how we address the users. So while the early adopters of additive manufacturing were willing to experiment, were willing to try out things, and were willing to have the one-size-fits-all machine and material and did some magic to that, when we want to go to manufacturing, then we need another experience of additive manufacturing. To basically lower adoption hurdles, we need to establish a it just works experience. So you buy a printer, you bring it into your manufacturing shop floor. Of course, you need to do some adjustments of that, but then it should have a high right first time level. You should be able to integrate the additive manufacturing production processes into your general factory shop floor applications and combine it with the manufacturing execution system and so on and so forth to just have another tool in the arsenal of manufacturing technologies. And we need dedicated solutions to solve specific problems. So with that, let me dive into the second element, into technology, digital and AI. So we have come a long way when we think about the advancements in the past. And let me jump to that page directly. So what we see at this year's Formnext is, I think, 2 key themes in this block. So one is technology advancements, and the other thing is software embedding and Gen AI. On the technology advancement side, I think what we can see is not new fancy new printers with even now 100 lasers or something like that. No, we see robustness and durability. So the equipment manufacturers are doubling down on enhanced durability, on enhanced robustness, and process security of their printers, and that will help us to actually integrate those printers into the production environment. We see also automation coming through quite significantly. So automation in the sense that it enables continuous unattended 3D printing, where we have longer production runs where we don't need basically a person at the machine all the time. So reducing the manual labor and thus improving efficiency in the processes. And also improving efficiencies basically in the post-processing steps and automating that a bit more. And we see production speeds picking up. So the latest printers improve productivity by up to 50%. But at the same time, what I also see is that when we speak about robustness, automation, and production speed, it's also about upgradability of existing machines. Yeah, so while in the past we basically had a new machine every year coming on stream, and that's the new greatest thing. So now the equipment manufacturers think about how we can actually upgrade our installed base, and so that also helps basically to convince the users of the technology to actually do a buying decision at the end of the day and buy a printer because they know next year or in 2 years or 3 years I can still upgrade that machine. I don't need to basically scrap it and buy a new one. So I think a lot of things are happening on the technology advancement side to robustify the experience, and that also, of course, leads into a higher manufacturing application. On the other side, we see a lot of software topics this year on the Formnext. So where we have software corporations, where we help us to have that digital integration of software, advanced software, connecting 3D printers with the shop floor of factories and so on. And we see a lot of Gen AI applications that help us to have generative AI, simplifying the 3D modeling, simplifying the orientation, simplifying and supporting basically how we run the lasers and so on and so forth. So a lot of things are happening here. Third trend, sustainability efforts. I would like to take a bit of a different perspective on the sustainability efforts and think and look at it through the lens of the user of the technology. So how can additive manufacturing actually drive forward the sustainability agenda of manufacturers of the users of the technology. And when we look at that, okay, rather complex slide with a lot of words on there, the simple message basically is when we look at the value life cycle of a product, so product design, raw material sourcing, production process, product delivery, product usage, product disposal. So, and then when we think about what are levers that additive manufacturing are bringing to the table in order to support the sustainability agenda of our clients at these angles, I think we can also have a different discussion or another discussion with the clients, because at the end, again, coming back to the value point, we help to solve a value problem that users of the technology have. So one of the value problems that they have is that their customers eventually also expect a positive impact on sustainability when they buy the product of that manufacturer. So how can that manufacturer with their products have a positive impact on sustainability? Well, here are some of these examples. So when additive manufacturing allows for an optimized design where we can have lighter products, you use less CO2 emissions, or you generate less CO2 emissions during the usage, basically. Similar on raw material sourcing, with additive manufacturing, you can bring the material there where it's needed in the product. We can reduce material usage of natural resources. We can shorten delivery cycles and shorten delivery lanes, so having a positive impact on the transportation side when it comes to CO2. So a lot of things that we need to think through, and not just saying, okay, what's the energy consumption of our printer and what's basically the rate of virgin material that we use in our printer. So it's really, again, my message, let's think where we can generate value for the end user and to build that story. Looking a bit at the time here, let me move on to material innovation. And on the material innovation side, we see also here on this year's Formnext a lot of new advancements also for sustainability and diversity. So first of all, we see cost efficiency of the materials. So cost is coming down while we are moving from that closed to an open system. And when we look at the material prices, we see quite a decline actually there. So that allows us to unlock new applications at scale, basically. Second element, again, sustainability, but here not from the customer angle, but sustainability of the process of the material itself. So we see a lot of bio-based and recycled polymers, so less virgin material used in the production processes. We also see, when we look at the materials that are used for photopolymers and so on and so forth, a trend towards less hazardous chemicals in those materials, and quite some advancement in that area. And then the third element is basically features and diversity of the product. So we see high performance polymers, we see composites now available that were not available 2 to 3 years ago. We see conductive materials, we see flexible materials, biocompatible and absorbable polymers that also can go inside the body. So a lot of advancements here. And again, coming back to the value question at the beginning, so we need to identify specific use cases and applications with specific materials and specific printers, and I think we are making a big step towards the specificity that we see there. So with that, my key takeaways of today's talk, and basically also of my visit to the Formnext, is that first of all, the additive manufacturing market is undergoing a consolidation phase and faces quite significant headwinds. When you look at the last 2 years in the additive manufacturing industries, a lot of players tell me that they had a very harsh time. But I think the signs are coming together that the next months are going to be better than the last. So I heard some positive signals here as well. So I think we are still on a growth trajectory, a bit slower growth, but still reaching roughly 90 billion in the next decade, and then going over the next 2 to 3 decades to a take rate of 1 to 1.5% of the global manufacturing market. So quite a sizable market eventually. Then advancements, what we'll see over the next years are manufacturing readiness. It will be a doubling down on technology, digitalization and AI, on sustainability and on material innovations. And this will shape the future of additive manufacturing. And last but not least, and that's always the angle we should also take, additive manufacturing unlocks value in manufacturing through multiple levers. It's not just the direct cost comparison, but we need to find those opportunities and where we can help the users of the technology, and that will further grow will further fuel the growth that's not yet unlocked. With that, thank you very much. If you want to have some further reading, as mentioned, we have been one of the first consultancy companies to realize the transformative power of additive manufacturing and have been regularly publishing stuff. And if you have any further questions, let's raise them now. We still have roughly 1.5 minutes, or send me an email or contact me via LinkedIn. Thank you very much.
Yeah, a round of applause for Wilderich. Thank you very much. Yeah, I think it's very impressive to have such an in-depth look at the numbers. We had a discussion here one on the other time that US is investing a lot into new technologies like AM. In China, everybody says, okay, we don't know the right numbers, we do not have the figures, but what we think there is a lot of money going into the investment. And in Europe, there is the mood of nobody is doing anything for us to push and to hold against these the two big markets. What's your opinion on this topic?
Yeah, so agree. So in Europe, we are facing harsh times at the moment. So when we look at interest rates, when we look at the general market environment, especially where we're here in Germany at the moment, people are pushing a bit on the brake in terms of capex spending. I think we'll overcome those times. So there are always times in the history when certain areas are a bit weak. At the moment, Europe is a bit weak in terms of capital spending, but you mentioned the US. I think we see a bit of an uptake there as well, quite significantly in spending on additive manufacturing. China is also a very interesting market. Also, when we look around here, then we see a lot of Chinese players that are promoting their products here. So it's a very interesting development, and it fuels basically the dynamics and also the rapid change that we're seeing at the moment here in the market.
And where do we have to look at who must be the one to make the government spending funding? I don't get which kind of funding that should be to help the market, and who would be the right person or entity to force or to give a backwind to some funding project. What you could mention here next year? Oh, that was very helpful. So that it really helps growing.
Yeah. So I think one of the key things is that none of the players in the industry would be strong enough to actually do that. But what we have seen here on the Formnext and what I also presented on these initiatives where we see partnerships coming together, I think that is a major unlock. When we have those partnerships along the players.
You mentioned AM Navigator, for example.
The AM Navigator or the Leading Minds consortium, basically, that are forming together. When we bring the players of the additive manufacturing together to speak with one voice, then we elevate basically also our standing towards governments, towards programs and incentives there. So I think that is a key trend, or that's a key step to form these partnerships to take the next level in additive manufacturing.
Okay, and additional, we had the partnerships here. We had Spain at the stage. We had Finland at the stage, and they want to close together to have a single voice as well. So that would help too.
Absolutely.
Okay. Yeah. Thank you very much, Wilderich, and again applause for your insights.
Thank you.
And I wish you a very good rest of the day and a good talkings here. And if you want to make contact to Wilderich, you know we had the LinkedIn live stream, and there you can have a comment, and then I'm sure you will look at these and give an answer.
Absolutely.
There. So thank you very much, and again a big applause.
Thank you.
So the audience, we are approaching the end of the international melting spot of additive manufacturing worldwide here in Frankfurt at Formnext 2024. After a short commercial break, we will sit together in our last afterwork session and welcoming the movers and makers of Formnext.
I'm here at the BEAM Symposium and I can't do it too loud, but this is a great place for architects and engineers to get new inspiration on AM.
Summing up the BEAM event up to now, I know it's not over yet, but what's the big news?
The big news? We're really getting to a level that we see these technology in construction. Construction industry is very conservative. Obviously, we don't want that building collapse. So we want the security. And with new technologies, it's always something which takes a decade, 2 decades, 3 decades to get into our construction industry. And we are now at the level that we really see not just the early birds, but more on a common level that these technologies are adapted.
There are so many ideas and so many different levels of ideas, but most of it focuses on the CO2 reduced usage of material in the production as well as in the material itself. So those are the things that I found very exciting.
What you've heard at Beam so far, is there any technology you can immediately put into a use case when you go home? And if yes, which one would that be?
Yeah, straight away. So we're working on designing 3D printed furniture. One of the problems with 3D printed furniture is that it becomes very heavy very fast because of the techniques within the plastic themselves. And what's really interesting about one of the technologies that we've seen is that they're basically inflating a 3D printed line as it goes around, making it very light. And so it feels like your lawn furniture, right, when they're making it. And this is super interesting for us to integrate to our next piece of furniture.
I might have picked a slightly unsuitable outfit for a business event like Formnext 2024, but I might just find somewhere where it's exactly right. Follow me. Wow. Hi, I'm Sylv. What's this?
Hey, I'm Cosma. This is a moon rover. Students like me built it to take part at a challenge called NASA Rover Challenge in the US.
I'm impressed. Can I jump in?
Yes, of course.
Take a ride?
Take a seat and let's go.
Wonder how fast this goes. I'm a bit scared.
We'll be surprised.
Hold on tight. Ah! Cosma, does it have a horn?
Of course.
This is fun, it's great. Woo! Do you need a license to drive it?
No, on the streets you don't need any license, but you should be sure that you are able to drive this vehicle.
Yes, well, it's pretty hard, it's good leg work.
How was it?
It was a hell of a ride. That's great, thanks. Oh, wow, thank you so much. That was fun.
I'm happy you liked it.
Loved it, great. Are any of these parts 3D printed?
We now mainly use it for prototyping, but let's see what the future brings.
Let's see what the future brings. Who knows? In the future there might be entire carts printed in 3D, except for the wheels, of course.
That's my first time at Formnext, and I'm having a good time. We can always see like nanotechnologies and all the things that are like, oh, those are really cool. I want to see how that works.
This is basically the forefront of what is possible. The fair is exceptional. The meeting point is perfect.
I really love the whole discussing points with the guests here.
Be able to talk, to have support, that's always for me a very important part.
I really like on the Formnext to see each other and also to see what is going on.
And even though it's a business environment, it has this flair of closeness.
Maybe I come with an own booth.
Welcome to Formnext 2024 and welcome to our last session here on Industry Stage, our after-work talks, or we can say after-show talks, because that's the last session we will have here. Time runs fast. Now the Formnext is nearly over and we are looking into exhausted faces, but they are smiling. Here with me, on stage. There's Petra Harburger, she's president of Mesago. Sascha Wenzler, vice president Formnext. Christoph Stücker, also vice president Formnext. Congratulations, Christoph.
Thank you very much.
And of course, Sven Krause, my beloved co-host here. President of the stage.
Wonderful.
Let's say president of the stage of industry stage in Hall 11D72. Yeah. Before I want to know about your feelings and your highlights and what is driving you or what has driven you to the stage the rest of the week. We have prepared for you some highlights from the fairground. We had some, we wanted to know from the visitors why they are here, because we are doing everything what we are doing here is for the people coming and looking for technology. And so we had a look at the visitors and let's have a look.
That's my first time on Formnext, and I'm having a good time. We can always see like nanotechnologies and all the things that are like, oh, those are really cool. I want to see how that works.
This is basically the forefront of what is possible. The fair is exceptional. The meeting point is perfect.
I really love the whole discussing points with the guests here.
Be able to talk, to have support, that's always for me a very important part.
I really like on the Formnext to see each other and also to see what is going on.
And even though it's a business environment, it has this flair of closeness. Maybe I come with an own booth.
Yeah, there is shouting for Formnext 2025, but we are not there at 2025. We are still at 2024. But you see smiling faces from the visitors as well. And Petra, how are your feelings?
Well, I think it sort of summarized everything we had here during the last 4 days. And I just said, I think I have to just show how my feelings is. My voice is absolutely gone. I think for me it was all in. From everybody, also from my side. But it was so rewarding, and also looking at the feedback that we just saw, I think it just summarizes everything perfectly. I think it was rewarding for all of us to see what we worked for during the last year and what we achieved all together, and that was a great teamwork. And I think this is just cool to see that it also was received so well, and that everybody really said this was the place to be, and we're happy to come back. Perfect, even with an own booth, as we said.
So as a good English shot with
thanks to you
with a good portion of honey, that's always helpful.
Yeah, guys, friends, what can I say? Maybe like in the very first beginning, it's exceptional how this community cooperates, collaborates, how they communicate. We created really a home base with Formnext for the global additive manufacturing community. They feel at home here, and it starts right from a one-man show. Even some guys having not founded a company, winning the Rookie Award, and going up to the largest industry players in the field of mechanical engineering. And all of them, they still live in a challenging time. The economics are like they are, the politics are like they are. But after this week, not only I, but we can feel a kind of positive impulse out of these halls.
Definitive an energy here, yeah.
And that's exceptional, and that's absolutely great. It's a good message towards the end of the year, and to really continue the work on AM becoming industrial, on AM becoming more and more common.
And you saw that this is not a motto, what you makers just a wish motto, let's say. The people come to stage and say, oh yeah, I saw something industrialization here, industrialization there. We had Sven on our stage, people who said, last year there were some prototypes and I don't know, stuff so a bit funny or so. And now I go around and see, we unfortunately didn't have the chance to go around a lot, but people come here and say, I see industrialization at the booth.
But it's also, you know, Frank, a match between the smaller machinery and up to a whole range of a full process manufacturing line, because some of the challenges and questions still relate to both of them, and it needs this interaction. And I think this was even more visible this year, that it's not a separated world. It can contribute to each other, and it needs this communication and collaboration.
But I've also found, I attended a networking event by our partner country, Australia, on Wednesday. Sasha has a little pin here, the little kangaroo. And without wanting to take this away from Australia, because that's exactly their forte, they have this can-do attitude. And it's also our community, our additive manufacturing community, that has a good proportion of that. And that was, again, you could feel that on the show floor. You could feel that in our talks. We have a full book of potential partnerships, collaboration, projects. So that's our takeaway, I guess, our homework now for the next year, up until Formnext 2025. So yeah, no, it's a fantastic feeling to feel this energy on the show floor, in our talks, on the stage as well, of course. So yeah, really looking forward to the next edition, of course.
And I look forward to the weekend.
Well, that's first things first.
Same here.
And you are.
We had a nice meeting before. You know, there were so it's not my expression, but I found it very nice. Now we need a kind of decompression over the weekend.
Yeah. So true. And
with Ingwer and honey.
let me quickly add. It's funny, and probably Frank can agree. As a moderator, you are kind of the thermometer of the mood of the fair, because they're all coming here, you're talking about the topics, and it's so interesting to see over the years how it develops, how it elaborates. Yeah, and I remember last year, kind of very, very bad moods from time to time, and you had to struggle a little bit. And if you see it this year, it's not longer. You don't need to be shy anymore to take the word industrialization in your mouth. That's
that's totally. That's a good point.
So the people are not afraid of saying it, that we got to this stage, and as Petra already said, it's all about collaboration, to be honest, and you as well, Sasha. If I see now, we had this morning AM Navigator, which is, in my opinion, a fantastic initiative, which brings the different process members and stakeholders together and make a holistic offer, and that's what I think that missed in the past, basically. And
exactly. And
I couldn't be more excited for the next year, to be honest.
I always remember the manual for building the starship out of the Lego pieces. So that stuck in my mind. That was, I think, a really cool picture.
Yeah, the whole technology, the whole tool in the toolbox, it needs this collaboration effort, because it will stay a highly complex process, and it's not only one process like we know, it's many of them, and a lot of technologies involved, and and also some of the high professional talks we had, they also had a result that the projects are there. The projects, because of the economical situation, they are pending, but they are there. And now also these projects, they go more into the step, hey, let's do it, and let's re-begin the projects again. Let's start the projects pending, because you can't let them laying down forever. Now it's this push as well. So coming out of these halls, and to give you just maybe one more fact, we are running above the 33,000 visitors. So that's a slightly plus towards last year, around about 3 or 4%, which is also exceptional. in this surrounding. So it's great.
A lot of companies are not allowed to travel at these times. So then I think that are very good numbers.
That are good signals, and I think also we as business people or in general as people we need these kind of impulse platforms or hubs to take away something from us, to not only V-cards or not only a bad throat, but we take away out something positive, I think, out of this week. And
but the good thing is, I think, everyone is so motivated. You don't need to infuse it; it's already there. And every year here on the show floor, it just comes out of them really, and surfaces. So that's.
But not to make it too much important, but I can tell you, if you compare it to other events, Formnext is super special in my opinion, because I mean you are used to it because you are focusing on Formnext. But Petra, you mentioned SBS. I haven't been there, but I tell you, if you visit other events, this family perspective, and that's the advantage of still quite a small industry. This really helps you in difficult times, because like in a family, you get closer together and you work more together in order to reach a common goal. And this is the spirit I take with me all the time. So you come back here, it feels like coming home at Formnext, to be honest. It's really the case. And you leave like you met old friends, and now you're motivated and engaged, as you said, Sasha, to now get to work and get things done, because this is what it's all about.
And you can't plan it. So frankly open, we didn't really expected it for this year, because like you said, Sven, by the end of last year, the economical downturn really began, and it was this situation when everything was running down. So what do you expect of a show right in the middle of an economical downturn? We were really thinking, hey, will it work out? How will the mood be?
I wouldn't say we didn't expect it, but I think we were not sure, I would say.
And then suddenly after the first or second day, that's exactly this feeling here inside. It's really absolutely.
But it also shows what mindset can do. How powerful mindset is. And I think it's so much about psychology at the end. So if you always talk about bad things, you don't feel good. If you just overcome it and you're positive, then you achieve something. So I think even though my throat is bad and I'm looking forward to my bed this evening, I feel recharged somehow. So I think the batteries are recharged. I think after the weekend, we roll up the sleeves and then we start going into the next level somehow, with all the great ideas that we got as well. With partners, what you talked about, so many ideas came up. That's like we have so much homework to do, I think now, sort of sorting everything out.
Great point for maybe a little bit of a sneak outlook.
One point I wanted to make, but it's not just talk as well, because obviously we had our Formnext Awards this year for the first time.
True.
It's not just talks, and it sometimes feels a bit like we want to innovate our way out of this, and especially with young innovative companies or ideas that come to the market. So it's not just talk, it's actually doing things.
And before you come with a sneak preview, it was so crazy to see at the awards how they were excited. I mean, you can see it's a difficult times, and you get awarded, and it has a totally different meaning in such times. And I mean, when you looked at the faces, they were it was like Oscars, basically.
I know it because I sat there. It was so great to see that, the joy as well, right?
But sorry, Christoph, now into the future.
But Sven, you can continue. I'm very curious about the AI and metaverse topic. I couldn't attend your last panel discussion, and that is for me a kind of an technology or topical outlook as well. Can you share a bit? I think it was a really good panel.
The first thing is, honestly, on a last day, you do not expect too much from a panel, because everybody's tired and get together. And this panel was awesome. It was crazy because they were sharing perspectives, and this is the stage we are in. We are not like we do have solutions. It's more about sharing perspectives and at the same time expectations, and get things in the right perspective again. And it was so helpful to have somebody from outside who explained us how this really works. So this was super inspiring. It scared a lot, to be honest. Don't get me wrong. I went out super scared because with all the positive outcomes of artificial intelligence, especially for our very digital industries, there's still a lot to do in order to prevent misuse and to get the right results. Let's put it that way.
So you should watch it in our live stream recording on Formnext.
I haven't seen a single
it's
presentation, but I watch them all next week. So I'm no meetings. I'm busy.
But coming to AI, you know, it's a bit like maybe AM 20 years ago or something.
Absolutely.
You know, then maybe some guys sat together talking about, oh, what's happening there, and in a couple of years we will print everything, and we need to regulate, we need to have an IP protection because it's a digital manufacturing process at the end. And now we look at AM becoming very industrial, becoming a very good tool in the toolbox. And yeah, the next step is, which is logical, that it will embed AI. And yeah, but that's a responsibility. That's the responsibility of all the players. How to also embed it in a reasonable way.
Yeah, and they both are similar because they infect all the other industry sectors. AM does this and AI does it as well. So they are really good comparable.
And one mini point I want to add here, because we really need to sometimes point out what Formnext is pushing forward. Look at sustainability. I remember we had a focus on sustainable, I think 2 years ago. Then we kept it, and this enables us to see what the progress is. And when we had our sustainability panel, it was crazy to see on which level we are compared to 2 years ago in terms of life cycle assessment. And the more our industry gets industrialized, the better we can do these LCAs and get harmonized. And then we have the arguments to push it even more forward, because you can prove it by the numbers. And sustainability, very important, is not about environment only, it's about the economics as well. So I love this the same way as AI.
Exactly,
it's so progressive.
It will stay a meta topic. It will never go away, and now it will be amended by AI, and behind AI a lot of more industrialized buzzwords like machine learning, like seamless workflows, all these things behind, and it's still a way to go. Because everybody, and that's another point maybe, or another word, it's realistic. So now the talks,
you can work with it.
The discussions are very, very realistic when I compare them even to 5 years ago or 8 years ago.
Discussed it, and sometimes you get a lot of new questions, but you can answer them, and then you can work. You know, so it's just a slow downer, and then it goes up again. And I hope, I hope that sometimes things like a digital twin, they seem to be very complex. Digital twin of a product, digital twin of a process, digital twin of, I think it's very complex, and AI could be helpful here to make it less complex. That's what my hope. But let's have an outlook in the direction of what's coming with Formnext next time. This morning we saw it in the morning news that we know already about the partner country next year, Christoph.
Yeah, it's true. I mean, you leaked it already, so...
Right, you were.
Yes, I think it was predicted.
That's journalism. Journalism.
Investment, yeah. That's right. No, our official partner country next year will be Spain. We are in talks with 2 wonderful organizations, Adimat and also IM30 Hub, who are very strong strongly connected to the Spanish market. And we will bring a strong focus on the Spanish market here to Formnext next year. But also in the lead up to it, of course, there will be some touch points in Spain, including some tapas and wine possibly. But yeah, no, we're really looking forward to it. It's another.
And you need a good moderator then.
Yeah, well,
okay, good moderator choose Sven. But if you need a second class moderator, I join you.
Spanish speaking.
Yeah, I will do the Spanish moderation.
El jefe está muy exigente.
Un, dos, tres, cuatro, cinque cervezas per
Una
favor.
cerveza per favor. Ja. Also ich wäre gerne.
No, but really,
I would like to join you.
Already, Spain is very strong in Formnext. With I think it's the 5th place of exhibitors.
Yeah, that's
strong
exactly. So it's not a choice by accident.
Yeah. That was answering my question. The reason why I had on lips.
Yeah. So we also saw in the last couple of years a really growth of the additive manufacturing industry, the ecosystem in Spain, the suppliers and the users, and this year Spain is the top 5th international participating country. So it absolutely makes sense to put a spotlight on Spain.
From my point of view, it was an excellent choice because we had Spain here on stage and Finland, and they already are talking about the collaboration, the working together, the groups, and so that the people behind the activities in Spain are very much focused on building the family, on letting the family grow, as you put it. And so, from my perspective, I'm very happy. I'm looking forward to getting the tapas and the red wine next year.
Yeah, I'm looking forward to the food selection of the birthday party.
Yeah, right.
It should be according to the partner country.
It always is.
Yeah, so that sounds really good. Yeah, I think we have a little bit time left, so I want to have a very short round about. What are you going to do next week? I had the question here on stage. Do you have in your private workshop a 3D printer? And I want to follow up that. What do you do next week with your 3D printer at home?
Actually, I don't have any, but maybe I get one. Who knows?
So we have to make an.
We always have this discussion in our office, Christoph. We should have a 3D printer.
Maybe in the Formnext office, that would be cool, yeah.
And
Christoph, at home, no 3D printer?
No printer, no.
No, but maybe this is so typical, you know, if you have to do with it all the time, and then you don't.
The shoemaker
put it
has a hole in his shoes. Yeah.
Exactly.
Yeah, but you know, yesterday I took my son a little bit around and my daughter together with the family, and maybe you know, I always try to inflame them about what I do or what we're doing here. So maybe the wish list for Christmas.
Okay.
There might be a printer on it, and then you know,
So you add it on their list?
Daddy is allowed to use it, right?
Yeah, that's the main thing. So I can admit, I'm not allowed to tell my brother-in-law, he will kill me, but because of the brand I'm going to buy. Because I consulted a guest on stage, Joel Telling, and asked him, what shall I start with? So I will buy one for sure. And I don't know, I think I start with something for the iPhone, because this is when I came in touch with additive manufacturing. I want to print my own cases. That was the first one. And Arno's always said, oh, forget about this, the idea is so old, but this will be my first project.
Okay.
So, and we can learn from you, and you give us some tip about which printer would be good for us. I want one definitely too. So, yeah, thank you very much, you four, of being here with me. The last presentation, the last session on stage, for a great week and for tons of experience, Sven. You have a job to do with me.
Thank you both.
Yeah, definitely. Thanks a lot, guys. That was really cool.
But that's a very good hook. Before we close the stream, I want not only to thank you and us. I want to have the whole team on stage. And Sven, maybe you come with me in our presenter position, and the team joins us on stage. You know, when we are working here on this stage for 1 week, you know, there are a lot of people who support you, who tell you when you're doing something wrong, to give you kudos when you're not sure, or when your English is not perfect, or something else. And when I think it's the same for you. We both are doing the same. So sometimes I say, Sven, why have you done this and that? And you say, Frank, that could go another way. But if you look behind us, then you see all the people without these people, it's not possible to do a job like that. We are always standing here in the front, but behind us, these people, they are the real important ones because they make the show happen. So now we can have
Cheers. Thank you,
a small drink. Thank you all. Every single one of you. A lot of people are already at home, so they already moved. They went away this morning. Petra, thank you very much. And I wish a good way home to them as well. Yeah, unfortunately, I have to say that was it for some of you, because without you, we need you behind the cameras. We need you. It's a picture behind the. Sorry, it's just a brief thank you, but otherwise we cannot go further any single step here. Yeah, so. I'm waiting. Yeah, you can stay with us. Stay with us. Stay with us. Yeah, sure. Stay with us. I need a red light to make the closing. There is a red light. Thank you out there. Thank you, Sven, again. Thank you, Sasha. Good that you're here with. We had a week full packed with news and informations. I would just want to point out. That you may follow Formnext at social media, on YouTube, on LinkedIn, Instagram. You choose your platform, but make sure to follow. If you missed anything, make sure to look at the media library at Formnext, so you can watch every single presentation here on stage. And yeah, I think, my dear audience, it was a pleasure. It was good for working with you, Sven.
Yeah, thank you as well for your interest, for your passion, for following us. And we hope we delivered a good program for you. And we are so glad to see you next year here on the stage.
So, my audience, thank you very much. We see you in 2025, Formnext here in Frankfurt, Hall 11, D72. We will be there for you. Let's keep growing together and stay tuned.
See you guys.
Let's take it real soon. You know we got what you need, baby. So take it real on. 1.